Hey Vince, thanks for joining again. Um, I forgot where we left off. Quarks Y assembly. That's what we're doing. I should probably put the chassis down on the floor. Yeah, I enabled the stream elements. I need to figure out how to configure it for auto mod. So far, it hasn't been a problem, but I realize that the only way to run a stream is to automate a lot of it. Um, like, where am I going to put the chassis for now? I will put it over here. Oh, on the floor. I'm running out of space. Okay. Um, let's do this. So these are on the Corex Y parts box. Rod holder. These two pieces. So these are machined aluminum. And then we're doing M3 by 10, M3 by 6. So last night after the stream, I got so frustrated with the trying to find stuff in little baggies that I sorted them all out into the bins. I didn't put labels on them, but I know what screws are which. And there's a chart, which is actually surprisingly really handy. So just to show you the screw chart really helps. So M3 by 6. Yeah, I just emptied all of the little baggies into a bin. So I highly recommend having one of these if you do any Prusa kit. I should have done it from the start, but I kind of wanted to get this done. So M3 by 10s. These are M3 by 6. These are M3 by 8s, and then these are M3 by 10s. So 5, 6. The Core XY plate, which I have right here. Yeah, I'm cheating on the Haribo. And I'm putting it the way that they show it in the picture. There's 3 screw holes. Or 2. So just don't completely tighten them. So M3x10 here. Back them out a little bit. These machine parts are really nice. They're um, like I could see the machining marks here, but they're black anodized. And like you can feel, I made that sound, but yeah, you can feel, I mean, these are definitely aluminum. These are very lightweight, but probably 60, 61. But machining and anodizing a complex part like that, this is probably I'd probably do it on God, I don't know if they do, because these are radiused. So they probably do a setup where they block it up here, machine it, turn it around, block it, machine it. And it might be, there might be one operation like this to do the slitting in the hole. But they might also do it on like a stock, basically a live 5-axis machine where they can like hold it together. I don't know how these are machined. These are a little bit simpler, but this is still a 3-operation, a three up setup. So a side profile and, oh yeah, side profile and top profile. So maybe a 2-up situation. Plus they have to tap it. Oh, wow. So this is counterboard on one side and threaded on the other side, and it has chamfers. Yeah, they spent a lot of money on those parts. I can't believe they can do that, basically. Like, I think even if you look at like China like a Chinese manufacturing company, they would probably simplify the part, or they make it more complex, but they just absorb the cost of the machining. Because it's still operator costs unless they fully automate it, like lights out. But I doubt it. Like, I bet there's somebody loading a machine with hundreds of these. Okay, let's see here. Place. Okay, same orientation. Okay, I have a chamfer on one side, I guess, because that's where the rods go into. They're very slight chamfer. It'd be hard to see that. Oh, underneath it, you're looking for the slots. Okay, so that's correct. So the little V-shaped pieces have to go inward. Place the rod holder left to the left front corner of the corresponding thread. That's really narrow, so I gotta use my Allen key set. Also, last night I pre-assembled the filament sensor. I was going to do the LCD as well. The filament sensor is pretty cool looking. It's a really cool setup, which I can show. But like, I realized that because I'm doing a Core 1 Plus upgrade without the parts printed already, I would have to. I might have to reprint some parts. So, and sure enough, I did. So I ended up using my positron to actually do the assembly of the kit of the Core upgrade, Core 1 Plus upgrade for the filament sensor. So the filament sensor, as far as I know, works. Yeah, it's not that difficult, but it's more important to have the parts printed before you tear your printer apart, especially when you're doing conversion like mine. But luckily, I have a positron that can print well. So the positron came in handy. I also printed my kit didn't come with a lubricator for the bearings, so I printed one on the positron, and it worked really well. So highly recommend it. I'll tighten most of these down. I don't know how much they have to be tightened, but so it snowed last night. So I was like, I'm not going anywhere. I was going to use the reflection of the sun on the snow to like light the room. But right now I'm using basically a shop light, like a garage light that's really bright on an old lamp, and it's just shining light throughout my room. And my room is painted white, so it basically reflects against the wall. But I think in the future, I'm going to mount actual panel lighting, LED panel lighting around here, like a softbox. Okay, yeah. Yeah, it does help to have another printer if you're building a printer or upgrading a printer. So I think if you were to do this upgrade kit without having access to a printer, then yeah, I would probably just order the $10 kit from Prusa. And again, you don't have to upgrade the Core 1. It's really just nice usability features. It's not anything necessary to make it function. But I think Prusa just decided to upgrade all of them because there's no reason not to upgrade to the latest one when it's just a few upgrade parts. The Core 1L is kind of now the flagship, so they want everything to match that flagship. My pet peeve right now is that now the Prusa XL needs the same filament sensor as the Core 1, in my opinion, because that is one of the issues. Is you basically have to bypass the sensor if you want to do any kind of flexibles. So I think the current Core 1 Plus filament sensor would be more useful, and I think they should do the same spool holder, because now the spool holders aren't going to be compatible with the XL if they use their new dry box. And then the vent grill doesn't matter because the Prusa enclosure, the XL enclosure, doesn't have that, as far as I know. So, but yeah, do we have rod holders? Just absolutely making sure these are in there. These CNC parts, though, remind me of the Voron V0 kit that I built. Cyborg makes a CNC kit for the Voron V0, and it has a lot of these machined aluminum parts that are anodized black, and it makes the printer so much more premium. But functionally, I don't think it makes that much of a difference. I would not want these to be printed parts, though, because of the accuracy. It's easy to just see the picture of the things. Okay. Bearings. Looks like they're using new pulleys. PT220 pulleys from Electronics and Fasteners. Oh, it's in here. I did organize it so I could find this stuff. But honestly, it doesn't take that much work to upgrade the Core 1 Plus. I think the only thing you have to do is take the side panel off. And I think for the vent grill thing, you can basically do that inside the cabinet. I think you can do that while you have the panel off to make it easier. I believe these are N3 by so we're sitting down. But yeah, I would not be surprised to see the same Core 1 Plus upgrade parts on the XL. And if somebody hasn't designed it, I will probably go and design it because, like, I want to kind of redesign the filament sensor a little bit, add a little bit more sophistication. But really, filament loading is like so much easier than having to do it manually like the old days. You know what I mean? Where you just basically push it up until you think it gets caught, and then you have to push it in there, make sure you feel it actually feeding in and stuff like that. So there's printers have come a long way. It's not like we're having to oil or filament or anything, like filament oiling, and because our hot ends are poorly designed. And now, like, we have big drive gears for the filament path or dual drive gears. Like, nobody's using a single narrow bolt for that stuff anymore. It looks like these are symmetrical, but they usually label the part if it's not symmetric. Yeah, it doesn't look like they're symmetric. So to make it look like the picture, there, they just say E1 and they look identical to each other. So the pulley blocks are, as far as I know, when they're mirror symmetry, it means the pulleys are going to be opposite of each other. And we have 4 pulleys. And then we have M3. There's 8 of them. And just to verify, oh, I'm pretty sure that's an M3 8 by RT. And verify that they are Torx. Yep. They fit better with the Torx wrench than the Allen key wrench, which you can swap between the two, but you shouldn't. And then I believe these are the 18s. Right here. I can kind of visually see the difference between the screws, but like, I'm talking 2 millimeters, it is hard to see if you don't have a reference. Like, if you don't have 2 screws right next to each other, you won't know biggest. But yeah, if you just hand me a screw, I can guess on the size based on scale to like a known object. But like, I don't know anybody who can actually sort bolts by just looking at them without any kind of reference. But like M3 by 10s we use so much that I can kind of recognize an M3 by 10. 1, 2, 3, 4, 5. 1, 2, 3. Okay. Now, one XY carriage orientation shown. These bevel side as guide. Insert the idler. I do wish instead of screws that they used pins, and I also see that they add a little bit of a bump in the pieces to space the idlers, because most forons use a stack of washers and parts. Uh, hey, Porsche again. I've done a Core XY assembly before, but um, you have to make sure that these things are absolutely square. But yeah, there's a lot of threading in the plastic that I'm not comfortable with these parts. And I do know one of the steps is you're basically lubricating the bolt so that the bolt doesn't create friction in the threads, which is the tensioner idlers, because you actually have to tension the belts, but they have a lot of friction on them. So you can actually strip the plastic out, I think, if you don't lubricate the screw. Um, but in my opinion, why not just use a capture nut? Because it's metal on metal contact. It might be a capture nut, but still, you're creating friction because you have a lot of tension on these bolts. It says to do one at a time. So turn the part upside down, insert another. I think it's the pulley in here. Yeah, so you actually put a pulley. And I have cuts on my fingers and it's really annoying. Both thumbs have some kind of cut from work on Friday, and like I put band-aids on it and antibiotic cream, but like I need to put, I don't know, I need to wrap my thumbs in something better than a band-aid. We have a ton of medical supplies, so I can just wrap it entirely with a gauze or a finger splint. But it's my lesson that I should always wear gloves when I'm moving material, because that's what cut my fingers. So they do have like a pretty, like, don't over torque them, but you can feel when they're snug. The idlers are like that. They're actually quite loose. They have a little bit like probably 0.5 millimeter of tolerance. What you don't want, what I don't understand is these are 3 millimeter ball bearings, so they're pretty small. You have a screw and no sleeve. So when it slides up, when the bearings slide up and down, if the belt isn't perfectly level, but you don't want these to be so stiff that they don't have a little bit of flex to them, because the belt, will just basically tear itself apart. Okay. So they're just building these idlers pretty much identical to each other. Another thing we're gonna get to is these metal brackets. The squareness of the gantry is determined by these brackets and the belt tension. So if your belts are not evenly tensioned, these can actually bend a little bit. And unfortunately, I think there should be a better solution for squaring. You have to make sure that the bearing is centered before you screw it down, because you just damage the bearing. Hey, welcome. Thank you. Yep. These are definitely quality parts. I'm gonna give you that, especially with all the PCCF that they use for these high temperature parts inside. They're all printed on Prusa machines, and I think they're one of the only companies nowadays that still print their own parts, besides Lulzbot. I think Lulzbot also does it too, but there's not a lot of printer companies now that are using 3D printed parts for their production. And I get that there are pros and cons for that. One being cost, because I'm sure it's a lot more expensive to have. It's probably a lot more expensive to do the amount of print farming that they have in labor versus just an injection molded part. But they also can do stuff like the Core 1 Plus upgrade kit, where it's just you print your own parts to upgrade the printer after it's shipped, and modification, right? They design these printers so that you can modify them. That's, the Chinese printers were just so cheap that people modify them, but they don't have the source code to go off of them. The only one that really was fully open source was the Ender 3. As far as I know, it was fully open source. But then Bamboo came along, and if you can modify Bamboo, but it's a lot of times it's people reverse engineering their stuff. And you're replacing injection molded parts with printed parts. So, but they're doing it because they're basically able to offer a printer for half the cost, and they're doing a lot of stuff in their proprietary software to make it a good user experience. Prusa has to do both. They're doing lower volume, higher cost printing, but they also have to do support and 24-hour support, and they're printing parts instead of injection molding them. Mainly for complexity too. Like trying to injection mold a part like this would have to be in multiple parts, injection molded. But it's good to see that they're starting to use more machined components in their assemblies for precision, because plastic parts can degrade. These aluminum parts will last forever. Well, at least until the bearings fail. But it's an ethos thing, right? Like I probably have seen at least 2 to 3 times more people buy Bamboo Labs printers than I have seen people buy Prusas. And I think it just becomes, what concerns you about buying a 3D printer. Is it ease of use and take it out of the box printing? Sure, both will do it. Is it that you only have $500 to spend on the printer? Sure, I understand that too. I mean, I was in the camp of the $300, like, what's the best $300 printer? And that didn't really exist until 2018, 2019 with the Ender 3s. I never had an Ender 3 though. I was pretty much always using CMC stuff. And they were not cheap. They were definitely the high end of US made parts. And they weren't even the high end. Like, these are better built than the CMC printers were. But, CMC also was an injection molding shop, so a lot of their stuff was injection molded. I mean, they still are. They have the machines. But as far as I know, their production is just wind down. But I feel like they're still making printers or printer kits. Like, I believe you can still get one from CMC. But yeah, they don't market or anything as much anymore. Okay, prepare the left side. That's this one. This is the left side here. Attach one of the XY carriages to the linear holder. Looks like that. And then we're using M3x8s, 18s. But yeah, I think like essentially what they're doing is building a Voron style printer. Like having a RepRap printer that also is, having a RepRap printer that is consumer friendly is a very hard position to be in right now. People still think 3D printers are like the science experiment that you have to tinker with, and they're not quite that anymore. Like a lot of stuff has been handled with software and better electronic design. Yeah, thank you for joining. I am on the Core XY stage. I pretty much have this. After this is bodywork. Core XY, and then the next extruder is its own. The next extruder is separate, but once this Core XY and the next extruder are all tied together and belted, that should be the next couple hours. So I should by this evening have everything to the point where I can just quickly, because really after that, the bodywork and electronics and door stuff is really easy. I've done that before. So I'm pretty familiar with it. Plus, I did the filament sensor subassembly. LCD subassembly is not super complicated, but there are some tricks to it. There are 3 bolts. The precision on these bolts are pretty tight, so you have to make sure that they're lined up perfectly. Like the metal and the plastic part are basically within, less than half a millimeter, 0.2 millimeters or so. Yeah, we're talking a few thousandths of an inch precision, which is great. That means the printers print their own parts accurately. That's good to know. That said, there is always, there's still room for error for warping, but they print really consistently. And I also know that they go through a lot of quality control steps when they print their parts. I'm just seeing if there's any asymmetry on here. It says install the linear holder with 3M3 screws, turn the linear holder upside down like this from with the torque screws. Okay. Yeah, I don't think my hands are calibrated, but if I was to do this, what I want them to do is I want them to give a torque spec, at least for consumers, that I could get a small little micro torque wrench and just verify that I'm tightening these correctly. But from feel, I know that basically if you're turning like with your fingers and you can't turn anymore, that's enough torque. That's about like half a Newton meter or half a Newton force. Newton meter of force. Like I can thread this with my finger and it backs off. And then with like a standard hand grip, if I can basically twist my wrist and stop it, that is enough torque. If you're stripping plastic with that much tension, then something's wrong. You also see that I do opposite corners when I do screws, so that I'm tensioning them in a cross pattern. That's just a mechanical thing that I've picked up, and I assume most people do that, but I can't assume that. They don't really tell you this in the book. It doesn't really matter for them, but yeah, the little tricks that I've learned is just cross pattern. Okay, assuming the next one is going to be exactly the same. If anybody has suggestions for a desk mat, I like this cutting mat, but the cutting mat gets warped and dirty and messed up. I think silicone mats are pretty cheaply available now. Problem with silicone is you can't really cut on it and it will get cut up by the thing. So if you guys have a recommendation for like a good desk mat for like working, neoprene is okay. Maybe like I was thinking about doing like half because I also solder a lot on mats, and so these cutting mats kind of get torn up by soldering. So I think a silicone side and like a cutting mat on top of a silicone mat would be a good work surface. Because underneath this is just polyurethane butcher block, um, which like you cannot get butcher block tabletops anymore without spending a fortune. I don't know what it is. I think the labor got more expensive, but before COVID, you could buy a butcher block tabletop for like $100, and now I think it's more. Um, eh, with the LTD screwdriver, I don't think I have a Torx bit. Yeah, they don't. It doesn't come with a Torx bit set. But I think in the future, I think I need to buy. I want to buy the longer bit sets and get just all the common metric and Torx and Phillips and flathead. And I think I can fit that in there because you can fit 12 mini bits and 6 standard bits. So like if I just had the ones that, yeah, see, I'm even trying to tighten it with the arm bit. If I had the standard um uh I can also add extra bits too. There's like a ring holder you can put around the shaft or here that has the extra bits, but I feel like that would get in the way. Um, but yeah, I would like bit types, but I want them kind of for stuff that I normally do, which is basically 1.5 to I think 2.5, 3, and 4. Uh, and then maybe a Torx T T10 and maybe a T15 or T20. T15 probably and T10. Um, and then I always need like a Phillips 2 and Phillips 1. So yeah, I'm pretty much using the same bits I'm using here. Um, but I really do like the LCD screwdriver. But I think for a precision kit, and LCD does sell a precision kit, but the iFixit kit's pretty good too. You go through and tighten them again. Okay. Um, oh, that's kind of clever. They're using the frame as a guide. Oh, these are called linear holders. I guess that makes sense. I call them carriages because they ride on a rail. So our thing that rides on the rail is a carriage. So this is your X carriage, or your X carriage is actually the what the print head attaches to. These would be your Y carriages. And then we need to get smooth rods and N6 bolts, which I have here. It's speeding up progress so much faster when you have stuff sorted. I'm realizing that. Although, oh, I have it all on the desk. Yeah. So what they're referencing is the rod holders that I took from uh what I have from the original Mark IV. So we're using quite a bit of the hardware on the Mark IV. Um, I would say about 50% of my like part cost is the Mark IV kit. Um, like the steel parts and the machine parts and the printed parts are pretty much all Core 1 specific. I'm going to go through and clean these again, but I can still see grease and stuff on them. And we're going to just put grease over them again. Also, every time I use alcohol, it feels great on my cuts. Now, oh yeah, I can see all the grease that was remaining on this towel. I am not sure if they're going to require a 10 millimeter bearing lubricator if these are not pre-lubricated. I'm going to assume that they're pre-lubricated, but I can't assume that. I wish they would like pre-lubricate the bearings for you. Yeah, so M6. Gotta make space here. For M3x6. Another way you can tell bolt size is the proportion of the head, since the head is always the same size. If you see that, like here, head size is 3 millimeters, and you can kind of see the proportions. But yeah, I'm using the chart just to make sure. Yep. So these are M3x6. Plus, this, you can tell if they go too far down. I'll get that later. The 8 millimeter bearings I have repacked, but the 10 millimeters I have not. I might have to print the 10 millimeter bearing lubricator. They should come pre-lubricated though, in my opinion. The screws are facing inward. Line up the ends of the rod holders. Push both through the bearings of the front. They don't mention anything in here since these are brand new bearings. I can tell that they are greased. I can see the grease marks. So I know these have been pre-greased. And they don't mention it in the instructions to grease these. They only mention it in 8 millimeter rods because those come from the Mark IV kit. So, push both smooth rods through the bearing into the front rod holders. Make sure the screws on the rear rod holder are pointing out of the frame. Line up the front end of the smooth rods with the front of the front holder. So they're a little confusing because it looks like this is, so we're putting this through here. And then it's through here. They feel pretty flush. Like, yeah, there's a little bit of grease on them now. And just to verify, I'm just visually looking at them. Yeah, they're pretty much in there evenly. Okay. And then these rod holders are flush with this, but they didn't tell you to tighten them yet, so. Line up the left rear rod holder with the threaded holes. And the plate fixed with M3x6 screws. Firmly tighten the screw in the rod holder. Line up the rear, right rear. These are the rear, by the way. We're looking at this upside down. These are actually the rear of the printer. But to go back to answering the question, yes, these are pre-packed with grease because they came from Prague, and they don't specifically say in the instructions. My opinion is that when you have to go, you're gonna have to kind of semi-tear down the printer if you want to do the threaded rods, or you have to replace the bearings. Like LM8 UUs and LM10 UUs aren't that expensive. The expensive part on this is that you have to get the whole machine part, because I think these are pressed into the block. I don't think these are replaceable easily without spending a lot of money on replacements. But again, the amount of stress these things have, I doubt they're going to need too much. And most likely what you'll end up doing is cleaning and lubricating the actual rail to just prevent the rails from going dry. Let's see. Yeah, so they want you to put the screws on there first. It's pretty obvious where the screw holes are. There's a lot of other things that mount to this frame, but I'm loosely tightening them. I believe so the parallelism of the bars, I don't think matters too much. I think the plate with the screw holes and the machine parts kind of compensates for that. Like, I don't think there's basically no play. There's very little play on the left to right here. Like, there's no way this would, like, the precision of where the screws are tapped and the precision of the through holes, like, you have probably like a few tenths of a millimeter at most parallelism, which I think is plenty for these. I've thought about that too, is like, how do you make sure that all the mechanics are parallel without actually like tweaking it? And I will say this bar, the parallelism of this is basically, they have a procedure where you basically push it up against the front and make sure that the blocks are touching the front and then tension the belt based on that. But if these get bent a little bit, you can actually bend them back so that they're parallel. In my opinion, they should have fixed that in software, or made added a physical end stop that's just for calibration, and then use sensorless for everything else. Because you could get away with, I bet you could get away with sensorless on one side and a mechanical end stop on the other side, and then that way you can kind of do like make sure that one is squared to the other. I think what will happen though is it will just give you a homing failed issue. Basically, it'll try to check the homing position with sensorless multiple times. I'm not trying to over tighten these two because I know the steel can strip on these. But yeah, it will basically, the XY homing will fail if your belt tension isn't correct or the gantry is not square. Because what will happen is it'll try to hit the corner, and it'll start racking like this, and then when it does its XY homing back and forth, it will be inconsistent because the gantry has too much slop, and then it'll tell you homing failed, and then I think you have to go back in and make sure the belts are tensioned and everything. So it's, in my opinion, not a ideal solution. They really should have done. Honestly, the only reason the Vorons are square with core XY is because of belt tensioning. That's why belt tensioning is super important, because it keeps your gantry from racking. And the biggest thing is that the software does not know that your gantry isn't racked when you're printing. So if you're printing with an offset gantry, then you're printing a trapezoid essentially. And honestly, if I was, probably one of the things I'm going to do when I first start testing this machine is print just a full volume cube. And besides shrinking, I should be able to measure the exact same dimensions across the diagonals, or else the machine isn't printing squarely. I believe I think the dimensional accuracy is correct on these machines though, because I think their configs are like really accurate, really good, and they have really good consistency. But yeah, like every printer I've had, you have to go through and actually dial in your XY dimensions, even though it says pulley and tooth and all that stuff. The Delta printers were notorious for this, and I didn't realize that until way later, when so I'm making sure that not skipping a step. I think they're gonna have you do the rod holder in the back. Yep. Left, right, left. Okay. But yeah, the Delta printers are bad because you're entirely relying on the kinematics, which means it has to know the arm length, and it has to know the tower height, and basically has to figure all this stuff out. It has to know all the values from the machine. But it can print at any scale based on arm length. So the thing is with Delta printers is your steps per millimeter is not directly translated to your millimeter specs, your dimensional specs on the part. So you have to basically compensate for it with scaling. It's which I ended up having to do, because my CMC Artemis actually was off by a few millimeters, and I didn't realize it until I basically was like, why is this part not fitting into this part? So I made a part out of wood, and I was trying to make a printed part that fit perfectly into that wood piece. And then I realized that the wood was accurate, the print was not. And that really was crazy to me, to figure out that my printer was not printing accurate the whole time I've had it, basically. Well, since I modified it, because I changed the arm length by changing the effector diameter. So yeah, these are consistent because they build them with the exact same materials. So if you make any mods to them, like use a different type of belt, you might want to check your dimensional accuracy, because it could be that the pulley diameter is slightly smaller or slightly longer. But if the pulley diameter is slightly off from the tooth count, like if you go from a 1.5 to a 2 millimeter tooth count, you might have a slight offset. And Prusa does bury their calibration, their step calibration, as far as I know. So people don't mess with it. But like I know with Ender 3s, if you change out the extruder, you have to change your E-steps. And like E-step tuning is a really important part, but with the next router, they don't even show you what your E-step count is. Okay, so these are all printed parts. So we're gonna do left motor mount, right motor mount. I do realize also that Steve from Steve Builds is doing a what is he doing now? I think he's doing a Trimax, uh, which is the Tridex, or the bigger Tridex, I guess. And I also know that Grant from Three Musketeers is doing a stream currently. But they go on forever. I might join them afterwards. But yeah, so far part quality has been super impressive. I have not seen a single defect. I'm gonna take a break though. So give me a second. I'm gonna mute my mic and go on break. I'm also gonna turn on the music. Oh, let me turn off the mic now. Okay, I'm back. I'll turn that down a little bit. Some interesting music selection. I'm just using YouTube's audio library. Okay, so assembly tool, which I already have. M3 by 30. And 3x18. I believe these are these are M3x30s. Spacer. Oh, they're really thin ones. I believe I already taken those out. They're in here. This music makes me think I should watch the latest Tron. I haven't seen the new Tron movie. And one single squirt nut. I believe the front idler also has the door switch, but that's not it. And these idlers here. So basically all of them. 2, 3, 4, 5, 6. I've been keeping the bags, but I don't need a bunch of little baggies. I'd rather print the bin that the things should go in than have to keep little baggies for things. So insert one pulley into the lower position. Now they're doing it like this, so this is a really cool jig. So you basically are putting the bearing in, then you're putting a spacer in, like that, and it keeps them all aligned, so you can insert them into the motor pulley system. Insert the second pulley, like so. I'm going to move this closer up. I think it looks better. There we go. So it's pulley, spacer pulley, and then we're putting it in the motor left and right mount. Position the start part according to the picture. Note the beveled corners. Align the holes for both parts and secure with an M3. Plastic part has no pre-cut thread, so screw cut thread as you tighten, slight resistance is expected. Just to verify, left and right are completely different. So they are different motor mount holders. So I'm looking specifically at this one because it has a taper here, the hex hole, and then this hole. And they're showing like the hook facing direct this direction, so. So I see the hole. M3 by 30. I'm going to make sure it actually gets in the pulley. And I'm going to start actually threading it into the plastic. Not too tight though. It's starting to spin, so I'm going to assume that it's in to the threads. And then what else do they want? Yeah, so that's pretty easy. But yeah, these should be in place. They have a little bit of wiggle though, so I'm not sure if that's expected, but they don't put spacers basically. They have one spacer in there. And this is a 2mm spacer. Because we've already used the 5mm spacer, so there's not really any other spacers. So it's a 6mm by 2 by 1 or by 3 inside there, so. So I'm going to do the same thing on this side. There we go. That spacer was not wanting to go in there. Okay. And then I'm assuming the next one is similar. No. I'm gonna put another pulley right here. What's also nice is they kind of give you a little bit of cavity so that you can kind of just rest it in there. And the bolt heads are accessible from the top. But now I know this plastic is quite soft, so. So the other one, they don't have through holes. So if you thread too much in the plastic, it will unthread the plastic. That's what I gotta avoid. So you're just getting it down to where it stops and stopping. Like there. So if you do too much, it will over tighten. But yeah, I think people are over stripping those parts, especially on the bottom here. And then insert the square nut. So do a single square nut hole. Okay. Do the same thing again, but position the part according to the picture. Note the bevel next to the screw hole. Align holes in both parts and secure it with M3x30 screws. So it's very similar. Like this. Put the pulleys in there. The start of the hole is threaded, or it's a little tight, so it gets threaded in. There we go, and then it pops. I'm just going to do just enough. Got the thread and it stops. That's it. Like, it should hold itself in. I wish they would do a lock nut on the backside, or at least a square nut or a something, a retaining nut, because one screw threaded in the plastic for pulleys to me is a bad idea. But again, I could probably modify this file since a lot of the printed parts are available publicly. I could just take the model and modify it. Okay. And then insert the pulley into here. Okay. I'm barely giving it any tightness with the screwdriver, just enough to get it to not back out. Well, we are using the pulleys. Nice. I think those are going to be your idlers. I think we got to do the idlers next. So those parts in here. For anybody following along, though, let me know how much different my assembly has been than yours. So I'm just kind of curious, like, these are not, what I'm doing is slightly different just because, probably partially because I have access and also access to parts, but also like I'm doing it as somebody who's built like 4-on kits before. But I am trying to follow instructions, list, step by step as much as I can. It's just some stuff is just super tedious. Like I'm repeating steps. I don't have enough desk space. I'm gonna put this up here on the workbench. That's why I'm starting I need the room for bins. I need bins on top, underneath. I need drawers underneath the workbench. That's gonna come next. I'm gonna probably get drawer carts that I can fit under my workbench or make them. But I want to basically have like top down, like have every single electronic component I could possibly need. Because I don't know if I'm going to do printers or electronics or most stuff that I want to quickly fix so far has been just soldering stuff. So I want to be able to have that stuff available. Okay, so we have the 2 pulleys. M3 by 30. 18. M3 by 12. I believe these are M3 by 12s. No, M3 by 12. 30s. And 18s. I know I'm redundant really checking, but I just want to make sure it matches exactly what they say. I had one inconsistency actually last night that I didn't show on camera, but I was building the Core 1 Plus filament sensor, and it tells you to get M3 by 10s, and then it goes to a step where it says use M3 by 8s to put the cover on. And then I went back to the Core 1 Plus kit, the non-conversion part, and it actually says M3 by 10s. So the only part that it says M3 by 8s is only with the Mark 4S to Core 1 Plus conversion. I need to put comments on that, because that is a big inconsistency. It won't make a big difference, but I think it's a little confusing if you use M3 by 10s or M3 by 8s on that step. Yeah, and then we're doing belt tensioners and the pulley parts. Yeah, so when you tension the belts, you're actually pulling an M3 screw through a loose square nut, which puts a ton of tension on that square nut. So that's why they're having you lubricate. They're gonna have you lubricate the screw. Yeah, and I think you're actually going to use the M3x30. Yeah, I can feel it. So just pre-thread them. And good. Yep, that's the step. So I'm going to put a little bit of lubricant with a Q-tip. Yeah, plenty of grease on that screw. And then the one thing I don't like about Q-tips though is that they get little cotton fibers in whatever you're applying. But I think that's plenty of grease. Oh, they're using a zip tie. Yeah, they're putting quite a bit of lubricant on that, but so they are marked L and R, and the pulleys are also correctly corresponded. So right, left, to EL, and then nut side up, and M3x30 going down through here. We use an Allen key. Yep, so these are loose. Okay. And then insert a pulley here. Use the M3x18. Insert the M3x12 screw into the tensioner. Tighten slightly, 5 turns is enough. Yeah, you don't want to overdo it. Oh, yeah, that's right. This is the door sensor, so it actually has a screw. This screw is basically, it pivots the door sensor in and out of the hole so that you can adjust where the door sensor stops. But yeah, M3x18. I want to make sure I'm doing it the right orientation too. It's from the side where the logo is. It's so much easier to do with a screwdriver and an Allen key. Yeah, I recommend getting ball end Allen key from the Allen key sets that are screwdriver handles. I find those are super useful. I don't have them. I used to have them, but I got them at my old job, and then I gave them back. But oh, what cloth? Sorry. Oh, ear cloth. Yeah, it should. Yeah, I'm just screwing it until basically it's flush with that side. I'm not tightening it. But yeah, it should be loose like that. I noticed the side with the bullhead has a little protrusion on it. I think that's so it doesn't crush. The bullhead doesn't crush the part. This is a really thin part, and it's printed in this orientation. So there's going to be a lot of the stress on the layers on this area. So it's actually interesting to me that they don't print these sideways. Like if they printed them like this, they would be a lot stronger. So it's making me wonder why they don't do that. I get PCCF is pretty strong stuff, but like you still gonna have layer bonding issues. I already did that. And 3x30s. Five of those. Oh, I missed this step. There's a screw that adjusts the end stop switch that I forgot. Not end stop, sorry, the door switch. Although, it gives me an idea. I think the door switch should be a mechanical end stop for the racking, so that basically turn the door switch around. So if the gantry hits, doesn't trigger the end stop, but the sensorless does, then it knows it has a racked gantry. And then you could also use the same I/O line by varying the voltage. Since it's basically using a voltage divider, I think it's detecting voltage on that line. But you could also do it discrete with a digital input. So you could basically have, is the door closed? Actually, no, even better. You basically have the door work on and off whenever you want the door switch to work. But in the calibration mode, it turns that door switch into testing to make sure that the thing is working. But yeah, you can put them in pair. You can put them in. I think you can put them in series. So we add another switch in series. I'll have the door open, and while the door is open, put another switch in series with it, so it knows that while you're testing it, that the gantry is not square, but it still can detect if the door is open and closed. That's a really good idea. I'm gonna suggest that. Because then it's only a minor change to like the idler pulley. And it just adds the cost of another switch. And maybe a little wiring harness. Actually, yeah, so the door switch would have to be replaced and with a second switch, and then that part. Okay, I'll think about that one. That's a good suggestion. I was even considering like to auto feed filament, have the print head touch a button. So when you want to load filament, it basically has the head go over to a certain area when it's not printing, and basically the touch a button that basically auto feeds the filament, and then when it's loaded into the head, it backs off, and that prevents the feed from happening. It's similar to what they do with the vent switch, where it basically goes over and opens and closes the vent really quickly because it's going outside of the normal print area and in a certain sequence, and actually pushing the slider over, which is a really clever solution. But I think there's just enough room where you could actually have it go to a certain area and click a button that would power feed the filament and then turn off. And then all that would require is just a mount for the switch. You could even do it even crazier and basically have it go over to a certain area with a Hall effect sensor or a magnetic reed switch, and actually just have it turn on the filament motor. Yeah, I think power feed is to me, I feel like all the printers nowadays have power feed. Not all of them, but like they should have a power feed option if you're using the standard spool holder. It also would really help if you're doing like an MMU setup, where instead of the MMU pull the filament, you could actually just have it feed into the inlet. but I don't think the MMU. I think the MMU is going to be as good as it's going to get. They haven't really talked about the MMU much. I would like to do an MMU because I think I have all the parts to do it. I have an old MMU2 that I can upgrade, and there's a 12 color MMU mod that's out there on printables, and I think it uses a lot of the same parts. And the only thing I'd have to do is create a buffer, which I think since I have the rep rack, I'm thinking about just installing the rep rack buffer, that spring-loaded buffer, and or mount the buffer to the underside of the rep rack, so I just put the filament directly into it. But yeah, then I can feed it into the MMU, which would feed it into the printer. There's a lot of options, because currently the MMU is mounted to a hood, and there's a custom hood for one, and then you need to feed the filament to that hood, to the MMU through the hood. I personally would like the MMU more than the index, only because the index is going to lose your print volume. You're losing about 10 millimeters of space on the front of the bed, and you're also losing a little bit of volume because you're having to put a purge block or a prime tower on the bed as well, which you have to do with the MMU as well. That's another mod I would like to do. I don't know if I'm going to go do it, but I like one that maybe where you have a little motorized purge bucket that only opens when it's commanded, so that way the print head doesn't have to go out of the print area to purge. It could actually just go over to the side, so your left side panel has nothing inside of it. I'm considering where I could just put it off to the side and have a little thing that basically pops out, purges into a bucket on the side, wipes out. I'd have to replace the whole side panel to do that, but I think it would be really nice to have a built-in purge and wipe system. But yeah, currently nozzle cleaning is kind of annoying in my opinion. The good thing is that you can modify a lot of the stuff with just starting G-code, so I don't have to require too much. And you can use the hacker board, which basically is a G-code command out. But yeah, so if I had a power feed, I could basically kind of write like a little load filament macro, unload filament macro, where it power feeds in and wipes and does all that stuff, all with like minimal original hardware. Let's see. Okay, so it looks like we're putting put the left. This one is the left motor mount. Have the rectangular protrusion cut out slide the motor mount under the yeah, there's a little nub here, and I believe it goes this way. Like that. Yeah, the locating feature is really nice. They call it a protrusion, I call it a nub. Line the holes and use M6 screws. Make sure I know where they're wanting the screws to be. They're putting out a second hole. Okay. Over tighten. I'm going to position the right motor. Looks like it's similar. Just mirrored. Up there. Slide the motor mount under the plate. Okay, and looks like the same screw hole on this side. So all the screw is doing is holding it in place. I don't think it actually is a mounting screw. It's much easier to get that screw started with the screwdriver than it is to do it with the Allen key. Alright, now we're trying it upside down. Actually, let me verify that. Yeah, that's what they showed me. So the idler's on this side. It's on that side, okay. Upside down so that the part bent face is facing towards you. Facing downward. Focus on the front left corner of the assembly, which is flipped around like this. Place the left tensioner left. Line up the holes on both parts. And 3x30. And an 18. I feel like I've done this before. I think I did this part of the assembly at work, but I don't remember the rest of it. But I don't remember doing all the sub-assemblies. I think I did the Core XY assembly for the belting. I just didn't do all the sub-assemblies. There you go. Damn. Alright, assembly. Screw head is facing outward. And this uses three 320s, yeah. So the remaining amount of screws. That's why I'm glad I take only the bolts that they tell me out instead of taking them out of a bin, because then I know I didn't miss a step. We're pretty close to putting the carriage together, I think. I think the X carriage is next. The other thing I noticed about the conversion kit is it doesn't give me the USB cable for the camera. So I might have to take the side panel out and run the cable if I want to do the camera conversion. So I have a feeling I'm going to be taking the Core XY on and off of my desk a couple times. Had to do any upgrades. Yep, that's correct. If we are to one of the most important parts. Let me put this up here. That's crazy that they can build this part. 'Cause it's not I don't think it's a steel extrusion. I believe it is a steel tubing that is a very specific size, but I'm pretty sure it's seam welded. You can see well, you can't see it, but there's a slight seam weld here, and then it's sandblasted and powder coated. But yeah, there's a lot of like drilling and thread forming involved. And this part has to be basically perfectly flat. Can't have a bow in it or warping, so that's a really important part. Again, like way overkill on the expense of that one. Looks like we're gonna use a couple M3x6s. Five. Paper towels. By the way, they use THK, which I think is a Taiwanese brand. It's not a bad brand. It's better than probably whatever generic Chinese component they give you. It's definitely not a high wing. Although a high wind bearing would be really nice. Actually, if it's a European country or company, they probably should use a like a Rexroth or some kind of German brand. But I bet that would even more increase the cost of this kit. This kit is already way up there. This is a surprisingly, if you consider self-sourcing of Voron, like a Trident or a V2.4, this would probably be on par with the cost. So you're really actually not getting too bad of a deal if you self-source. That might have changed recently, obviously with tariffs and everything, but like they are getting wholesale deals on components, but they also are trying to get the top quality that works for them and not just get whatever is available. But we also, Prusa, I don't think has the direct control like they do in the Chinese companies, where they can basically go to their next door neighbor, and if that component isn't up to their spec, they can like literally just tell them, hey, this isn't up to our spec, get another one. And then or they can go over down the street again and get like a different manufacturer of linear rails. Like, the problem is we don't have any competition. There's like a handful of US and European manufacturers of linear components, and they're really expensive. If we had more people making them and competing, in theory, you'd have better quality components available. But I believe they do not grease the bearing. I'm hoping they do what Ron's do and go through and re-grease the bearing. Nope. I guess it's pre-greased. I mean, it feels pretty sticky, like they have grease already in this thing. But in theory, yes, you could take this off, pipe grease in here. But it isn't smooth. It's I'm sure it can get worked in, but I wouldn't trust the grease in here. But I'm gonna follow their specs because I want to build this like a normal printer, and then see how crazy it gets. But yeah, they need to at least explain proper lubrication to the normal users before they start trying to build these like Vorons, you know what I mean? Like the Vorons, they have gone through and tells you exactly in the kit when to lubricate and where. And they was kind of standardized on the lubricant. It feels like a silicone grease, like they're already packed in a super lube. But I would personally probably just wipe super lube on here, because I have super lube and I pretty much use it for everything. Place the linear rail on the linear rail beam and line up the holes. Insert and slightly tighten. Okay. Did that. Use these pliers. Yep. I get another type of plier. My little Weatherman. insert the 2 screws into the 5th holes. Theoretically, you want to tighten from the... Yeah, actually, that's what they show. You tighten from the inside out. So you do tighten inside. Then you tighten these. And then you tighten the outside ones. That way you're not binding the rail. Remove the safety pins from the rail. Okay. And then we're doing N3, 8 RCs. Okay. Yeah, sure. This way. Actually, linear rail assembly holders sit on the front side of the assembly. This is technically symmetric. There's 3 holes here. This is Torx. I'm going to start from the center, put the center ones in first, and then kind of align it. There we go. Yeah, I can tell that all the squareness of this gantry is determined by these metal brackets. And honestly, what it needs is like a reinforcement here, like a precision reinforcement piece. Because I don't understand how they expect this thing to stay square. I mean, belt tension, even belt tension is basically the only way you can do it. But if it gets out of the square, it's just going to stay, it's going to spring back to actually, I'm to the point where I think they should just make some kind of gear motor that basically tensions and a sensor, a belt tensioning sensor essentially. Something that can adjust the belt tension automatically. I mean, they already have that in production. It seems like they teased that, but like, they were trying to find FFA tuning, but they really can't like add more hardware without huge production costs. I think that's what they're fighting, is having to make all these small adjustments. I think this might be easier if it was more floored. But like, I can tell that this thing is not square. Like, you can basically wobble this thing. So there's really nothing keeping it square mechanically. Besides, I think, what it's going to become the belt tensioners. There you go. If anybody has a Core 1 in the chat and is still watching, have you had issues with the gantry being racked? Like, where it doesn't want to home properly? And did you try belt tensioning first? Because I think belt tensioning is like super critical on this printer. It's like, you have to have this thing. And I don't know if, I mean, belts can kind of settle, so they're, reasonable. But even the ones I've used, the Core ones I've used, if they're going back and forth homing for more than like a minute, it's usually a belt tension issue. But from a fundamental design standpoint, I think that they should have a way to mechanically check if the gantry is square. See, on the CNC machine, you have two independent drive motors. One on the left, you have a y-axis and a y-axis 1, y-axis 2, and you can independently drive them. And so you basically just go up to where they limit switch here. With Core XY, you have to essentially see how this is not square. Your belt tension has to be perfectly even on left and right, or else your one side's going to be slightly leading or following behind. See, now I just basically tweaked it a little bit. Yeah, so I'm basically just bending it ever so slightly. And there's enough elasticity in the metal that it can basically hit the stops, the idlers, which is how it's basically ramming into the idlers for its homing. But yeah, I think there's no way to square a Core XY other than a single machine part, or that keeps it under tension square, or it has to be equal belt tensioning in the Core XY assembly. I don't know how they would fix that. Yeah, so you are belt tensioning basically. Yeah, but having built CNC machines in the past, and usually you compensate by having two limit switches. That's why I was thinking a good solution is that you take the input for the door switch and double it up so that it's on the left side of the gantry. So if this is hitting with the humming, and this is not hitting mechanically through a door switch input, then you know it's not square, and that and then it's a troubleshooting step. You just say, hey, tension your belt so that it's square. Because I think people just like don't know when it keeps going back and forth and fails at its tension, it fails its insta or thing. They don't know it's belt tension. I mean, it is pretty easy to fix this stuff, but wow, we're to the R&B side of pop. I want to switch genres. But it does slide smoothly, so it is correct. I'm off. Okay, I think the music stopped. Okay. So it says to discard the safety pins. I'm sure you can print plugs if you really want to take this rail off. Now we're doing the bed, stopper rear. I think it's one of the last parts in that bag. Yes, plus belt lengths have to be identical, really. Yeah, I mean, tensioning and belt length are important. It's just, I think fundamental issue with Core XY is that you don't really have equal belt tensioning. Basically, you have to be the belts always have to be under tension, and they have to be really tight. And pulleys can cause artifacts, motors can cause artifacts, linear rails can cause artifacts, like the ball bearings moving can cause artifacts. So you just have a lot of artifacts that basically are developed by a Core XY system. So to me, it's a compromise. Like Delta printers have artifacts because of the interpolation and the play in the effector. H-spots, I think, are really good, but you still have the same problems. Really, I was hoping that the Magneto X was going to solve a lot of those problems. Yeah. Doesn't need to match as long as the tension is the same. Well, on the Prusa it does, because I think they don't give you any slack. You basically have to have the belts. I think they tension the belts like based on the length of the belt instead of the tension. That kind of gets you the start of the tensioning, and then you go for, I think the idlers, these tensioners have basically a centimeter of play, which doubles up. So you have about 20 millimeters of stretch that you can pull the belts. So you have to kind of have them really tight to start with. Yeah, on the Prusa it does. On the Vorons you can pretty much belt it and kind of get the tension based on that, but you don't have a lot of room for idlers. Like the idlers don't have a lot of room to pull the belt, so you don't want, I would say like you have to be within like 1 tooth length equivalency. But they pre-cut the belts, so on this kit, if I'm going to use the pre-cut belts as they are, so they are going to be exactly the same length. Yeah, that's because your print block printer, the chassis is the tensioner. Your blocks have so much play in them that you don't need the tension. The belts just kind of take care of itself. Anyway, M 3x8. Dreams Void is messing with everybody. But yes, I have built enough printers to know that artifacts are always going to come from mechanical things and face stepping. Like all we're trying to do with input shaper and face stepping is compensate for mechanical resonances that come from the chassis shaking, the belts wobbling, the pulleys, stepping, ball bearings, riding not perfectly. The only way you solve it is you build a really expensive ball screw printer, like the Pantheon. I think the Pantheon is a really good printer, but like, and in the $10,000 printer range, I don't know if it's really the best. I think the HD90 is a nice package, and the Delta printer kind of compensates for a lot of stuff. It does print really well, because I have used the HD90, but I don't know. You're not looking for surface quality when you're making aerospace mechanical parts usually. You're looking for strength, so that's all about material properties. How fast and how hot you can print. Yeah, you tension off the frame. But really, if you're building, like, if I was designing a printer from scratch, like, I don't think Core XY kinematics are the best. I think they are the best that we have with the technology we got now. I think I could build a good printer with ball screws, but it would significantly increase the price of the printer. But I think ball screws and linear rails are probably the best way to go. But you don't need the torque, like, because ball screws have basically backlash. They're backlash free, and you're directly moving the carriage. You're basically eliminating any of the artifacts that come from a belt, and the precision is entirely from the motor movement. I will say servos are also really nice, but I think servos don't really help with 3D printing. They help a little bit because you can compensate for, like, you wouldn't have skipping of steps without faults. They're obviously really expensive, but yeah, I basically, if I was building a printer right now, I would build it like Luke's Labs printers or the Pantheon, where it's just ball screws, servo motors, going to a modern, clipper or duet controller. And then I would have whatever the highest flow hot end you could possibly make, essentially. So this triangle piece, insert the bed stopper under protrusion, align all 3 holes. It looks like the center one is basically threaded into the plastic. So I would thread it into the square nuts first to get it aligned, and then this is threaded into the plastic, so it says no regrets, Titan slight resistance expected, so they at least acknowledge that it's plastic threaded. I'm going to tighten these two first. And tighten this. I think we're really close to belting. I wouldn't be surprised if belting is the next step. Or putting the carriage on. The carriage plate should be next, I think. Okay. Okay, it looks like that. Oh, no, we're not done yet. Now the motors. I'm going to put this on this way. And then we're going to grab the X and Y motors. X motor, Y axis motor. And pulleys. By the way, they do not use Loctite for their set screws, which I've complained about, but they technically know what they're doing. And then the little tool, which, where did I put that little tool? Oh, it's right there. And these are 16th tooth, so 1, 2, 3, 4. Yeah, so starting for the set screw, 1, 2, 4, 5, 6, 7, 10, 11, 12, 13, 14, 15, 16. Yep. I counted them. And GT2 is 2mm pitch belt, and then GT, I'm not sure what it stands for, but I think it's the profile of the type of belt that you're using. And they're usually 6mm belts, unless you're using a 12mm or a 3mm. Sometimes they're 1.5s. So we're starting with the X motor, which is this one. So the flat part's facing me. Let me unscrew the set screws slowly, because it's not, they're protruding a little bit. Okay. So Oh, we're putting them on this one. What kind of music is this? Use the fork on the gap between the pulley and the motor. Push the pulley onto the tool and firmly tighten. The two sides of the pulley must be on the motor side. Yep. You don't want to strip set screws, but I'm putting a ton of torque on it. Okay, and then I'm gonna do the same on this one. I believe these are 3mm grub screws, so they have plenty of thread engagement. But I personally would put a little dab of blue Loctite on these. And I'm not going to, because I'm going to do it how they want you to do it. And then if it becomes a problem, I will fix my own machine the way I want. Okay, I think that's correct. Now the Y-axis motor. Oh, that's really clever. So they're using the spacing of the zip tie loop as the Y-axis spacer. That's really clever. That is cool. They do a lot with this little multi-tool. I think the only thing they don't do on here is... Oh, they do. They have a little cavity under here, and I think that's for... I don't know what that's for. I'm sure we'll find out, but yeah, a little cavity at the bottom, probably for tightening some kind of screw. So flat shaft facing towards me. There, and then use the hook on this multi-tool. Place the thicker curved part between the pulley and the motor. Do not try to hook it around the shaft, just rest the tool against the motor. And make sure hook tip slides between the motor and pulley. Okay, so you're just using the tip of the... You're using the back side of the hook. And I think that's so that you have any inconsistencies in the print height, since it's printed at the height. Yeah, you're not causing any interference, I guess. But you can't really sit this flat. It's not that much of a difference, but push this pulley onto the Titan screw a little bit. Oh, I'm doing that wrong too. So you actually are doing pulley the other way down. Yeah, you do want to pay attention to this because But yeah, the pulley or the tool, assembly tool, can slide under here easily, so you know it's in tension, and I'm making sure that the set screw is on the flat of the shaft, and then I'm doing the other one. Tension, tension, tension. There you go. So that should be correct. Just to verify. It looks like the picture. Oh. So the motor assembly, the XY belt. Oh, so now we're belting. So we are getting the carriage plate and the two belts. By the way, these are Gates Power Grip GT LL2 GT E 12025, blah blah blah. And they are, do they tell you how long the belts are? I'll verify for you guys. I'm gonna guess about 1.5 meters, but let's verify this. It's about 1.523. So a little over 1,500 millimeters. And I can do the same with this. Make sure I get the same result. This is not the most accurate way to measure. Yep. So about 1.523. So these are, as far as I can tell, exactly the same length. But I'm pretty sure we're going to be cutting some excess off. And then I'm going to, just to confirm, I'm going to zipper these together. And the ends should okay, I'm not showing what I'm doing. I'm just verifying if you zipper them together. Yeah, they're cut exactly tooth to tooth. So yes, they have the exact same belt length, which is pretty crazy. They must have a machine that like precisely cuts, measures the belt length and cuts it, or they have some kind of jig that does it, and somebody sits there all day and cuts belt lengths. I'm pretty sure they order it from Gates pre-cut, but or it's a Chinese vendor, I don't know. It's in China, there's probably a machine that cuts belts all day. And so there's an M3x35 screw which I think is in here. I didn't sort all the parts out because I didn't have enough bin space. But fastener bag 203 has we're getting there. 25. I believe this is it. And 3x35. And we're using 8 of them, which I think is the whole bag. Two, 4, 6, 8, and 1 spare. I think after I'm done, this divider bin's gonna be my Prusa spare parts bin. And it won't probably be organized, but it'll be enough that I can just reference back that these are all my Prusa hardware pieces. Again, I also am only going to probably have one Prusa printer. I am not buying multiple Prusa printers. I don't have room for them. And yeah, I just don't have room for them. So I would take a Prusa Mini because I think that would be a decent printer to have. But an XL, I don't know where I'd put it. I kind of want to keep with the funky printers, the ones that aren't like a normal model, make and model. I have grease on my phone somehow. Okay, give me 1 second, I'm gonna check something. If anybody is in the Dallas-Fort Worth area, there's a CO2 laser, a 60 watt CO2 laser. It looks like it just needs a new tube for a really good deal. Okay. I think we're a little slow, but we're getting there. I think we're pretty close to getting X Core XY done, and then really the rest is just a final assembly. It's not gonna take. I am hoping to get this done by like 8 or 9 printing by 8 or 9. I don't know if it's gonna be that easy, but I don't remember there being much calibration steps. Belt tuning is probably the most time consuming. And I think this is going to have a preliminary belt tuning before you assemble it. But I think they're going to have you do it with the app, which I am not a fan of, but Am I missing anything? Nope. First step is probably lay it down. So the x-axis is top position, y-axis belt in the bottom position. Yeah, red is bottom, X is blue. Okay, let's do this. I might stand for this. This might make it easier. Trying to ground myself somehow. Okay, from the core XY, actually, if you want to ground yourself for static, touch the screw on a switch plate. That's usually grounded. Okay, so from the back core XY, this is the back side. I'm going to focus on the left side. Create a loop on the belt, anywhere in the belt. Use this belt. Create a loop. So the belt teeth are pointing inside. Push the loop through the space between the lower pulleys inside the motor mount. Push through enough to make the loop follow the top hole on the motor mount as closely as possible. Insert the Y motor into the... Okay. Pull slightly belt loop. Okay. So I'm basically pushing the belt loop through here. I'm going to move the camera so that you see more of a top-down. It's not going to show you much of the belt tensioning, but this might help you a little bit. It's going to help me because it's going to get the camera out of the way. So you're doing enough that basically you're going to lower that, and then you put the motor, the X motor. So this is the X-axis motor. Oh, nope. That's why it didn't make sense. You're putting the Y motor in here. Yep, I felt it engage. And they leave a little window so you can see inside there. Firmly grasp the Y motor assembly and position the vertical. Do not drop the motor. Oh, got slammed. Keep hold of the motor with one hand and with the other hand secure 4 M3 by 35s on the other side and tighten firmly. You're going directly into the motor from the underside here. So you want to make sure that the M3 screws actually tension inside there. The belt does get held in place, so I don't have to hold the belt, but I'm just verifying that the belt is still in there. So I'm gonna tighten in my cross pattern. Okay. Yeah, so the belt, there's not really an easy way for the belt to come out with the motor in place. So, yeah, you can basically leave the belt hanging. It won't slip out of the pulley, as far as I can tell. Yeah, there's no pathway for the belt to come out. Okay, guide the left end of the belt around the lower pulley. Push the pulley, the belt through the part and guide it to the front of the coaxial plate. Do not pull too long so you don't pull the whole belt out. Remember, the other end is loose. The whole process would have to be repeated. Okay, so we're just feeding it through. So this is the left side. This is the belt side out. And it's being fed through here. To the front. And that's still there. I believe it comes out of the slit. There's a slot here that the belt comes out of. And the two side, I think, has a clearance, so it's not rubbing against anything. Because the carbon fiber filament could wear the belt down if it rubs anywhere. guide the belt around the pulley in the tensioner. Push the belt around the front of the pulley in the linear assembly. And pair the neck extruder holder in the same orientation of the picture. Push the end of the belt through the middle hole, end of the left hole bottom, leaving 4 to 5 teeth sticking out. Okay, so that's a lot of steps in one little part. So we're going around the idler. Oh, it helps if I do this. So we're around the idler. And then there's a pulley on the bottom of this. The plastic part is shaped so that you can pull the pulley through it. So it's two side against, the two side is actually against the pulley, flat, which I think should be a tooth pulley, but that seems controversial. And then you're doing the middle and back. And then that's on the carriage side, so. It looks like I'm doing middle, then back around, and only 4 to 5 teeth. One, two, three, four, 3, 4, 5. So like that much. Okay. Okay. Back to the other end of the belt, take the other end and guide around the lower pulley, push through the motor mount to the front, route the belt around the lower right pulley rail holder. So this is the lower pulley. Yeah, this would be really confusing to most people. I think, I mean, I'm a little confused just because I have to read the instructions how they do it. But like, if he just gave me a belt path guide, I probably would have to figure it out. From the picture. So it comes out the slot here. And then I'm going around the outside of this. There we go. Okay, so now it has a complete loop. Push the end through the middle hole and the bottom of the neck extruder holder. Have the 4 to 5 teeth sticking out. It is difficult to reach the neck extruder holder with the belt. You can loosen the belt tensioner screw. Okay. They should have like some tolerance here in this step. So 1, 2, 3, 4, 5. There's about 4 teeth sticking out on that side. So I have like 5 on one side, 4 on the other. And there we go. All the pulleys are engaged. Right floor. Okay. But mine looks roughly like that one. I think I have more on one side than the other. They're showing about 4 sticking out of the plate on each side. Yeah, so I'm gonna leave it like it is. It does seem to hold itself. Now we're gonna focus on the right side. We're gonna do the same thing, but on the top side. So create a loop with the belt 2 side in. Yeah, I think the XL, I think they're positioning the XL to be a kind of a professional multi-tool head thing instead of a printer, just a printer. But like, I don't know. I think their investment on just building a good consumer printer that has a good out of the box experience and maintainability and repairability is key. But I think it's more of who they market to more than what they're building. Because really, there's, if you're gonna build disposable printers that you can sell for cheap, not disposable, but you know what I mean, like a Bamboo Labs X1 or P1S or Ender 3 or whatever, you know, or Crowdy. You have a different market than if you're trying to sell something that like you want to work all the time, but also you want to be able to upgrade and, you know, long-term sustainability versus short-term growth, which I think is where Prusa is positioned. I mean, I wouldn't complain about an XL. I mean, the 5-tool head XL is still the best tool changer printer right now, but that will soon change. It is really hard to just build a tool changer. I think the Index is gonna basically be the Index is gonna be the game changer for a lot of it. I also noticed that I put the X motor on wrong. I might have to go back. Yep, I gotta swap the motor around. I don't think it should affect too much, but I should be able to just rotate it without taking the belt off. But I wasn't paying attention. Hey, Combat Gnome. Thanks for joining again. This is day 3, hopefully the final day. So I don't really have a lot of time to do it outside that. I might take you up on that. Depends on where you live. I forget where you live, but I don't mind doing this. Doing it on stream is a lot different than doing it where I'm kind of just messing with it by myself. It's kind of, doing it on stream is honestly a motivator where I don't have to just mess with this thing alone. Oh, I took the wrong screw out. And that's the other thing too, is if I did it by myself, I would get distracted pretty easily. It's kind of hard to say. I would kind of mess with it and then stop, and then mess with it and stop. And this is kind of getting my motivation to actually finish the project. Because then I just don't want to have a no printer. That's the main reason why I'm trying to rush to get this done, is so I want to have a printer available. Because I want to print gifts for people too. That is next. I don't have a lot of gifts, but like, there's a lot of things I haven't finished that I was gonna, I don't know, like I don't have my CNC router anymore, so normally like the last 2 years I've been making unique like wooden gifts out of like walnut and cherry and for my family, but this year I only have like a laser cutter and a 3D printer, which, you know, only a 3D printer, but like still I just don't like the look of 3D printed gifts personally, and there's only a handful of 3D printed gifts I could think of that would actually, like, they wouldn't just throw away or, you know, put on a shelf and never see again. And those are the ones that you take a lot of time to make, like multi-part pieces, or ones that take a really nice high quality filament, not just, you know, nobody just wants a box of plastic parts, you know. Like the octopus wine holder. I have STL Flix has a really nice octopus wine holder I want to make. Yeah, I'm definitely compulsive when it comes to having everything set up the way I want it. And if I had a third party moving stuff around with me, I would go crazy, because not that, you know, trust me, I would love to have kids, but they would be off limits. I would like their help, but just don't touch my screws. Because if I can't, I was freaking out yesterday. I couldn't even find a single spacer, and I put it in the box. Luckily, I put everything inside these boxes, but if I would have missed that one spacer, it would have stopped the whole thing. This whole project relies on you having like every piece, and they don't give you a lot extra. So if you misplace a screw, you might be screwed. I'm already struggling. Okay. Okay, let's go back to bell tensioning and put the motor on the right way. Hey, welcome, Nomad. Good. I'm still doing the Core XY. I've been doing this for like the last 2 hours. There is a lot of pieces, but luckily the guides are really good. There's not a lot of room for error, basically. Like, I don't think you can. It would be really hard to mess up some of these parts. But I mean, I know where you can. Like, if you're not paying attention to where to put the pulley or the wire, like I just did, I had to go back and fix the orientation of the wire. Paying attention to how many teeth are sticking out of your carriage. Verifying that the belts are exactly the same length, which they are. I double checked the belt length. Yeah, ensure the motor cable is facing near you, which is correct. Okay. Okay. But it's like little details like the locating feature. Of course, I just had an Allen key. Locating features to like center the motor so that the motor's like holes line up. Like that stuff's really important. Like where you can't twist the motor if it's in the right position. When you tighten, you know. But so far the precision is so tight that like you don't have to wiggle parts to get the screw holes to line up. You just put the bolt in there and it lines up perfectly. So yeah, like part quality matters a lot. Especially with these parts. But I kind of went on a rant about how there's really no way to square the frame or square the X rail. And it's all done by belt tensioning, but like it's still a manual process to tension a belt. And I think one thing we can do is make it so that it detects if the gantry is racked by using the door sensor switch. So running a door sensor switch in series, another switch that's in series with the door sensor switch, since it's in the same location, you can reuse the same wire. So basically have it guide. So basically it tells you to open the door sensor switch. And then while that switch is open, have the other switch detect if the gantry rail is being butted up against the part, and at the same time that so basically the switch would be like an end stop for just the left side. The right side would use sensorless homing to detect the stopping. So basically what you do is you figure out if the gantry is racked based on a mechanical switch and a end stop switch triggering at the same time, or the sensorless homing. And I think that would be able to detect the gantry is squared or not when it first starts. It would have to be a thing that you basically enable or disable. But I think it would be a good upgrade that you can do with just a single limit switch. A single limit switch, and then you just you have to reprint the idler, because I think you can mount it to the idler. I'll have to show you kind of what I'm thinking about, but I think it would be a really nice addition to your future printers to have something that can kind of detect gantry skew. The other way we could solve it is by just machining a bracket so that the gantry just can't rack. But I have a feeling it's not enough of a problem for people that they're gonna do it. Okay, it's as tensioned as I want to get it. And then I'm sure we're going to do the same thing with the belt on the top side. Okay. Both are screwed in. I'll take the right end of the belt, push through the belt guide. Okay, so right side, push through here. Guide the belt on the pulley tensioner. So up here. Route the belt through the upper pulley of the linear assembly. Route the belt through the middle hole. Okay. And then we're doing the same thing with 4 to 5 teeth. It's hard to see, but I'm making sure that the top and bottom teeth count are the same. Yep, they look about the same on that side. Okay. But yeah, you can see, you probably want to basically line up the top and the bottom tails to make them look the same right next to each other. I'll take the other end, guide it through the upper pulley, and push the belt through the motor mount. Okay. So I'm going through the motor mount to the slot, around the pulley through this side, like that. And then doing the same thing. There you go. Make sure it's not catching on anything. I want to make sure the bottom and top tails are the same. Yep, like that. I'm sure they're gonna have you double check too. Recheck the belt tensioning. So the left motor going around, idler, down carriage, down, around, here, bottom, here, and then the complete opposite, which is basically from the left motor up, idler, down, here, carriage, going loops, around, blue, top idler, carriage. Yeah, pretty sure that's correct. Okay, so now we're gonna get the Bowden guide. M3x10. Five. One square nut. Two zip ties. I forgot I also have to make the cable loom and the neck extruder. This is gonna take till midnight again. I might end up doing this Monday off stream, but we'll see. Because I don't know how much time I'm gonna have Monday, essentially. Ugh. Okay. These are all M3x10s. Yep. They're not having you check belts, but I'm basically making sure that the top and bottom, the tails of the top and bottom are basically identical. Yeah. It's probably easier if I flip this around. Yeah, I don't know how you would. You'd have to really make sure you don't pinch those belts. But it is seating on the metal, so. Yeah, they are very loose. The belts are very loose. It sure would be nice if I had some way to work with this RXY gantry. I'm glad that I have a workbench big enough to actually do this, though. It should be sucked to do on a little dining room table. Okay. Cables through here. Wait. I haven't. I pushed the wrong button. My fourth mouse button did something. I'm really close to done, though. That's a lot of steps. Okay. Okay. One zip tying. Push the zip tie through here. It looks like they don't give you much slack, so I'm just gonna do it straight down. They do it in such a way that you can still pull it through if you need to. But don't pinch your wires. There we go. I put the square nut into the motor out. Right here, square nut. The music stopped. Okay. That's tight. Doesn't interfere with the belts. Now the LED strip and the metal bar. I think that's going to be on the front. So with that, oh, I have to turn this upside down. Been quiet. Or RTs. The really tiny ones. Yeah. Ah. Something like that. After sticking, press lightly. Do not touch the LED resistors, which I keep touching. But I think they want you to cover up the LEDs here and center it with the slot. And you mount it. I don't think it matters that much, but what I'm doing is putting where the adhesive starts. I'm gonna put it on the giving myself about 1 millimeter clearance on the top. And I'm just kind of going through, peeling the tape as I stick. Why they have you not touch the LEDs is probably for electrostatic discharge, but I would. There's like no way to not touch the LEDs on these. You could technically get like ESD gloves, or I could wear my ESD strap. Yeah, that looks about right. Pushing all the sticky areas that aren't the LEDs and resistors, but I'm touching the LEDs and resistors anyway because I have big fingers. But I don't think it's that critical of a part. They just want you to orient the correct way, make sure it's fully stuck down. Take the white LED and attach it to the front. Which is, I believe, like this. Oh, you have to go inside. It's like this. So it goes under this cover and like that. Yeah, so it actually hooks underneath. Good thing is it's pretty easy to take that bar off if you ever want to change it out. Yeah, I'm kind of disappointed this kit doesn't come with the USB. So I'm going to have to basically take it all apart to put the camera on. I'm to kind of at the point where I think I might just do my own camera mod. Because it really just has to be an RTSP, or a camera that can do its own RTMP or RTSP. I'm pretty sure I can get away with a Pi and Pi cam sticking into the case, into the chamber. Well, it still has clearance, you know, but it also has to be a wide angle lens, which it'd be hard to get a Pi cam with a wide angle lens. I mean, they might have them already, but it would be nice to get a full blown like camera in there that can handle, you know, all the stuff. I'm checking this over real quick. It looks like Steve is still live. He's doing his Trimax. So I'm on 4 hours now. I might get to 8 hours. I'm really hoping to get this thing done today. So I'm on track. So by 4, basically by 9, I'm hoping to have the whole thing mostly assembled. Somehow my switch is down here, my door switch. I'm glad I found that. I am busting through this pretty quick. Oh, hey, I got the door sensor. I didn't even think about that. Door sensor. And they're in 2.5 by 10s, which I believe are these. One screw. And I gotta get another thing of zip ties, so 2.5 by 10. And I start a new bag of zip ties. Sorry, I'm grounding myself. I believe my LED light is also grounded as well. Okay. Try not to touch the rails because they're greasy. Thread 3 zip ties to the core XY plate, ensuring the zip tie heads point inward. Partially tighten and zip tie the stem to catch the first piece. Flip the assembly back with the motors facing up. Okay. Ow, that hurt. My wrist didn't like that. So we're on a left tensioner. I believe it's like this. So the lever faces upward. And I'm putting the screw in the bottom hole. Tighten the bolt fully and then loosen the quarter turn. Should be allowed to move from the rear of this belt tensioner. Tighten the M3 screw so it touches the door sensor. Okay. We're going to adjust this later, so it doesn't really matter where it's positioned. And it looks like this uses a 2mm wrench. There you go. And you gotta thread it into the plastic, so kind of gotta straighten it. Fully tension and then forward or turn. So it looks like they're tilting it back until it touches the corner. And then I'm going to use the M3 bolt to thread into the plastic. And that's really tight. I guess they don't want the screw backing out, so the tolerances kind of matter. Just go do this. And by the way, it's clipped, and it basically pushes up against the plastic piece. So there's not really a blocker or anything that prevents the screw from rubbing against it. And yeah, like I said, there's a voltage divider, so it uses a resistor between the common and normally open or normally closed. I believe I think it's normally closed. Or it might be, yeah, that's right. It's normally open, and then when you close it, it goes to the resistor. So when it's open, there's no resistance, and when you close it, there is some resistance. But yeah, you can see the resistor. Okay, push the zip tie through the hole. Yeah, that's good. It's kind of loose, but that's fine. The cable sleeve isn't moving. And there's enough slack that it's not going to get pulled. And they don't show it, but basically the cables, looks like both cables are going to route under the frame. I think that's the next step. So let's route them around the screw. Now prepare a cardboard box. Flip the core XI assembly upside down. Position the smooth rods on top. So I lift and support the front side of the core XY assembly with a cardboard box. Okay. So I'm going to grab one of the empty boxes. I think the printed parts one is fine. And make sure I return my Allen keys. I'll go crazy looking for them. And so we're at the LED cable, the zip ties. Oh, both, yeah, cable and door sensor. So Yeah, surprisingly, I don't remember doing a lot of this. I think Nomad did most of it, of this part of the section. I definitely remember building, um, I'm definitely remember the neck extruder. So I did build that, and I also remember building the rest of the chassis and doing some of the wiring. But like, there was, we did follow the same guide though. Um, so there's not really much difference in the Mark IV guide other than the prep for the parts. Um, but I think the main thing is the neck extruder is pretty much already assembled if you get it from the Mark IV. So you don't have to really do anything to the Mark IV subassembly other than mount it. So I'm hoping there's not much to that. Slightly lift and support the side LEDs. Tighten them. Cables must be slightly taut and straight. Excess slack and bends may cause collisions with XY. So these actually have to be flat. And what I would recommend is not overlapping cables. So I would go basically, yeah, it looks like they're going under the screw. But yeah, I'm going from the sensors and LEDs back. There we go. So I'm not doing them too tight, but I'm doing them where the cables are snug. And I'm just making sure the twisted are overlapping. Yeah, thank you. Yeah, I'm being very slow and methodical. This is not a normal thing. Well, I mean, it's normal for me, but this is not normally how I would probably build stuff unless I was, there's a lot of like, you just gotta do it kind of things, you know? And again, this is not technically not the first time I've built a core one. I have built one at work, but that was like 3 or 4 months ago. And I've interacted with a lot of the Core 1 part pieces, and I haven't done the Core 1 Plus upgrade, but I'm pretty familiar with the parts. So I am not new to any of these processes. What I am new to is doing it the way Prusa wants it to be done. But like, there's a lot of it is having context and understanding of like, okay, when they say be careful with how you route these wires because they might get caught. These are pretty taut. At least they tell you why you do it. I don't like places where they just do it this way and then don't explain why you don't do it that way. Because if there's any variance, people will overlook steps. Oh, 9 days? Yeah, no. They say, I've heard that 12 hours should be enough time to do a core one assembly. I don't believe that. I think 8 hours if you know what you're doing. But I think 12 to 14. It's going to take me essentially 20 hours to do it over a live stream. But that's because I'm taking a lot of breaks and I'm rereading stuff slowly, and each step takes me, 5 minutes to do. And then I go off on tangents. But if I was actually focused on this, yeah, I probably could get it done in 12 hours. If I didn't have streaming or anything like that. I mean, it looks pretty close to what they're showing. The other thing is, I don't want to have to do any troubleshooting when I set this printer up. I want it to kind of work as much as I can. Oh, I think we're mounting the Core X assembly. Here we go. This is a big deal. One screw. Okay. 2 rods. Okay. Please tell me we're putting this on. Yep. You probably will be slower. Yeah, I think a week, and it depends on when you start, because I don't do well with context switching, so carefully insert the smooth rods in the bed. Blah. Temporarily hang the cables. Caution. Do not lift the Core XY assembly. Always lift by the base of the entire assembly. Okay. I'm going to put the Core XY assembly out and get the whole piece. Yeah, if you don't have another table, if you don't have a full dining room table, this would be really hard to do. We did it in an office, but we had to have, I think we did it in the office, but we had to have basically, we had to switch to like multiple workbenches to be able to do it. This is starting to get heavy. Ready? Let me get my power supply out of the way. I have a DC power supply up here, and I still have the cables. So we're gonna move the camera to give you guys a better view of the whole thing. Go taller. There we go. Okay. Yeah, I totally think that $200 to $300 price difference of a kit versus fully assembled is definitely justified. This, if I actually got paid well, I could totally see that this would not be cost effective except for to enjoy doing it. But there's probably basically no reason you should have to do this to save $300. Uh, yeah, like it's not even the base. Like you're basically the minimum wage of like spending 8 to 12 hours. Okay, maybe if you not minimum wage, but you know what I mean. Like if you're making $15 an hour, putting this together, you would not be making good money. Um, yeah, the assembly is basically like the knowledge. That's the thing is if I did this full time, then yeah, I would like know the ins and outs on it, and then it would make sense financially to do it that way. But like for somebody who's never done a mechanical component before, the amount of troubleshooting and stuff you have to do if you do it wrong outweighs the money that you're saving for the pre-assemble. Yeah, I agree. It's entirely why I like doing this stuff. For me, it is entirely for saving money, though. In this case, uh, for me, it's saving money because I cannot afford a full kit. Um, Nor do I want to spend the money. And this is helping me though with my job because we directly interact with or one's assemblies. So knowing what all the sub assemblies are and why you do certain things the way you do makes a huge difference. But yes, I would have rather bought one pre-assembled if I could have afforded it. Um, but this is a cheaper solution. um, because trust me, I probably could have bought uh, a Snapmaker U1 for about the for less than the price of it. Um, for less than the price of like a used, even a new one of these. Actually, a used one. I found a used Core One on Facebook Marketplace for 1,100, and that actually is a pretty decent deal, I think. Um, I'm kind of avoiding the step. Temporal hand mechanicals. Okay. Insert the smooth rods through the heat bed assembly into the rod mount into the base assembly. It is required to insert the smooth rods into the axis with the bearing very slowly to prevent the balls from flying out. The end of these rods are tapered or chamfered, and they should go in pretty easily. In theory. There we go. Yeah, don't force it because the balls will pop out. There we go. Placing the assembly of the smooth rods and the back panel assembly. Ensure that no cables are pinched. Ensure that both smooth rods are properly seated in the rod holders. The threaded rod of the Z motor must pass through the bed stop rear part. Oh, here's an extra warning. When handling the printer, do not lift it by the core XY assembly. Always lift by the... Oh, yeah, duh. So it doesn't show it, but there is these printed rod guides back down here. And you want to make sure that they're fully seated in there. Because they're a printed part. You do not want to twist them like I just did because they lock in place. You actually want them to be like that, perpendicular to the screw heads of the motor mount. But yeah, don't twist them because it actually can pull out. So push them down, but just make sure that they're fully seated. Because you don't want them sticking out too much or not seated at all, and then they'll not guide the bed. So basically the Quark's Y plate and the base plate have to basically be equally mounted to each other, and it keeps these rods stationary so that the bed doesn't wobble. Because you can see if there's nothing holding it on there, the whole bed would shift and you get a Z layer. It just depends on what you value your own time. I mean, personally, I would build via pre-built, but for me, that's only because the urge of let's take that apart. And the other part of it, me, is like I want to be able to modify the machine, and so that if you build it, you can do all the mods you want easily because you already know what screws are available and stuff. Yeah, if stuff goes wrong, that too. It does help with troubleshooting, but it also helps me ensure that my printer is built the way I want it to. I'm the same with oil changes. I'm at the point where I'd rather do my own oil change, not to save money, but because I want to make sure that they don't screw up my car. Yeah, so I kind of treat this like an oil change. You kind of want it to be done right, and if I want to modify something on my car, like at least I know now where the engine is and where the transmission is, and I've done actually quite a few mods to my car. I've done the radio, backup camera, I've replaced the suspension components. So yeah, I'm definitely a DIYer. So it looks like you can just rest it on the mount. Oh, it's right here. God, I am really bad at seeing stuff. Anyway. I'm gonna route the cables so that they don't drop behind it. Here we go. This is the big important step. I feel like I'm hitting something. Oh yeah, okay. So here we go. All the way back and guide this through here. And then these rod mounts go here and here. Like that. And like these screws have to wiggle through this hole, and that goes there. Okay. And no wires are pinched. They're all free. I believe the fan goes through a hole and it doesn't interfere with the belt. They don't quite show all that, but they do tell you in the description. So we're gonna make sure everything is properly seated all the way down. And there's a little window, and you can see. I can also hear it snap, or kind of scrapes the aluminum into place, but you can't push. You can't push the rods down anymore. They're fully seated in there. There's also a screw head so we put a screw head in here, and actually it's resting on the screw head, which is fully countersunk. And then back here, the only thing that's going to hold this back panel together is these two holes back here. So it's the the back panel is your alignment for the back, and your the rods are alignment for the front. And that's how you prevent this thing from being tilted or skewed parallel to the bed. So the back panel is super, super important to the whole printer. Heck. In this, I'm going to use the screwdriver, so I make sure they're actually out. Oh, that's already tightened. Wrong screw. Heck. And I'm going to remove all the grease from here, all the grease from here, on my hands. Move the linear rail carriage to the center. Firmly tighten all screws. Push the linear rail down while tightening. Okay, so it's already in the middle, but essentially they want me to tighten each one in a certain order. I'm kind of loosening them. And then I'll retighten them in order. But this ensures that the rail actually falls down onto the screw head and kind of aligns itself to the gantry rail, because you can have a drop, so you can actually have a little bit of sag, and that will introduce errors in the print. Okay, tight one. Oh, I wasn't rattling, did I? There we go. So I'm pushing down on it. I'm tightening it. Okay. 2. Pushing down on it. 3. Oh, the ratchet slipped. Never had that happen before. Okay, 4. Shows you how much torque I'm putting on these things. 5. Okay, and 6. Okay. Oh God, that got really heavy. This is getting harder to move. Um, there's one extra screw. I'm not sure where that went to. I'm gonna go back and figure this step out. But I'm going here. And you probably can't see it, but I'm putting the ground plug on the XY lead, and I might have to use pliers. The whole printer is on the pliers. There you go. Much better. Okay. And then we're doing the X-axis cable. Yeah. Are they sending upgrade kits? I imagine, is it what, free if you just bought one after a certain time or something? I hope that's the case. I mean, honestly, it's just printed parts. You should be able to do it yourself, but it would be nice if they sent you the right O-rings and stuff. I think it's just, as far as I know, it's an O-ring and printed parts. I don't think there's anything special. The printed parts are, I believe, PCCF, so they do need to be, they should at least try to give you some element, maybe. But yeah, like an official upgrade would be nice to have. Push it up and make it look nice. There we go. Okay. And then we're gonna make sure they're not in the belt. They're behind the belts. Yeah. Okay. Yeah. I need to do a hard knuckle. It's another one of those things I want to put in there. I'm gonna push the connector. We get a stool because it's probably easier to get to. I'm too short for this workbench. There we go. That's much easier. That was tricky to get in there. Yeah, there's not a lot of clearance there. Eh, that motor goes in there. Oh, grab it fell out. Uh, oh, that's what that extra screw is for. Now, where did that screw go? I can't see it, so I'm just gonna use another one. But there is a reason why they had you get it out. Oh, fun. I thought you were supposed to get it by now. You didn't pay for rush delivery? You get concierge service and have a red carpet for you. I wonder what the shipping order is for the Core One else, because um, getting it directly from Prague sounds like a different, like everybody's gonna have a different path. I'm gonna look for this one little screw. I'll put this down real quick. I probably put it back, and I don't remember putting it back. Um, but these are rivets. Cool. This tool. I think I just put it back subconsciously. I didn't know where it came from, or it's on the ground, and I'll never find it again. Especially anything that's like a small black screw on a gray carpet would be easy to find. But when I put it up here, I probably knocked it out of the way. I'm just making sure I didn't miss a step. Um, you know what I mean? Okay. I put it so on the backside. Okay, so I think there's some wiring involved. So I'm gonna lower the camera further away, up, over. There. Okay. So route the cooling cables, fan cable to the left toe of the buddy box. Rubber grommets keep popping out. There you go. Put the fan wires on front. Yeah, I'm hoping I have a working printer tonight, but uh, I also need to work tomorrow. I don't have time off to take because I'm leaving Wednesday night. So Thursday and Friday, I'm taking PTO. So it's not like I can take the whole week. Because if I could, I would. Um,
So fan one, fan two. If I really want to be careful, I would do fan two on the right side facing the printer, and fan one is the right side. Not that it really matters, but it would be kind of funny if you could actually uh, diagnose it, which connector it is. Heck. And then looks like the sensor cable. The connector order doesn't matter, but it does. It doesn't matter, but it would be nice, I think left to right. Left, fan one, right, fan two. Add the chamber thermistor together with cooling fans connected to the second slot from the left, labeled temp. Hey. And they don't give you a lot of room in here. I'm gonna guess, if I had to guess, that the index control board is gonna go in the slot here, and it's gonna basically mount to the cover that goes over here. So I'm guaranteeing that they're gonna have an index controller inside here, because there's no other space to put it. They probably could put the index controller here, but I think because there's already a cover, they can just put a long control board that's basically hidden in here, and then all the cables out of the way. Because I think they're gonna have to run a separate power source. I hated the grommets. I forgot to put one in, so I had to redo the cabling. Yeah, that's the thing, is I think I'm gonna be pulling these panels off a few times. But again, the goal for this is to build it as Prusa designed and get it printing as Prusa designed. Oh boy. Guide to X cable through the right hole. Cool. Sorry, I'm had a message. I mean, we're doing wiring, so it can't be that far off. We just did the Core XY assembly. Okay. Yeah, these two holes are actually your alignment holes for the back panel for the Corex Y stage. So this is just a temporary holding so you can do all the wiring before you put the panels on. I don't know why they don't have you do that first, but connect it to the first slot from the left of the board. Here, so it's X and Y. So X motor goes to X, and that seems like Y. The guided door sensor for the right hole. I think door sensor is white and brown wires. So that goes in here. And that is the lower slot on the left of the side of the buddy board. Right there. And that looks like the LED through the cable, through the holes of the buddy box connect to the second slot from the extension board. It's funny because basically most of the expansion board is used. But what's cool is they have a CAN bus. It says pub CAN, and so it looks like you can actually send CAN signals to another expansion board. Okay, and then looks like we're going to take the Y motor to the left hole and the second slot from the left of the buddy board. So, and guide this around here. There's not a lot of slack, so there. Just to verify that these labels are upright so I can see them. This is step 80. Oh my God. Okay, good. That was a lot in one step. They really should break that down to like multiple steps. Well, they did it by how many steps? So, what is it? 7. Terrible. I got plenty left. Wasn't it €499 for a 4 tool head? I believe the upgrade costs, but those pre-orders were sold out, so I don't know when they're gonna have the new ones. Nice. Next extruder. Yep. Oh God, the next extruder. So here's the thing. I thought the next extruders are already assembled. So if you're following the upgrade kit, you theoretically shouldn't have to do any of this. Like, I'm not going to change this. I mean, maybe I should rebuild it. So anybody who's done the upgrade, do you actually rebuild your next year, or you just use it as it was? Ah, okay. Now it makes sense. So yes, I'm rebuilding the next year. Okay. Well, I guess I'll be an expert. Um, the upgrade kit doesn't come with any of the parts for the next extruder. I think the only thing it comes with is the side cover. I mean, these aren't PCCF parts. In the electronics package. Oh, the small bags part? Yeah, there's no electronics package. It definitely doesn't come with. It definitely doesn't come with a whole extruder assembly. Yeah, the tensioners aren't the same. Yeah, this is all fan shroud parts. The only thing I could think of is that the Mark IV-S has all that stuff. Um, and I have the Mark IV. But yeah, as far as I know, I don't remember seeing when I rifled through the package having any of the replacement parts. I mean, it's not going to stop my assembly, but I basically have to go through and reassemble, disassemble the extruder and reassemble it. Yeah, the electronics box basically just comes with just the electronics components. Um, I don't have anything left over from. I have the stuff that I had, my mods and upgrades. Printed parts box is empty, metal parts empty. Yeah, I think I'm gonna basically build it from the sub assembly. I will do is clean the fan and extruder. Um, yeah, the fitting, the bowden and fitting I got, but I don't have the PCCF parts essentially. As far as I know, I don't have the PCCF parts. So I think I can basically just get the printed PCCF parts and then rebuild the extruder the same way. Um, I'm basically just wiping the fan grills in here. I get rid of any residue. But yeah, I'm gonna have to take apart the extruder, and figure out the differences between what I have and what they have. The good news is that this might actually just speed up the whole assembly process. But yeah, for now, I think I'm good. Yeah, so I think because I'm building a Mark IV, the parts are not PCCF, but I don't think the extruder is fundamentally any different. The base extruder is. So what I'll probably end up doing is rebuilding the extruder when I get parts. So I gotta go find Mark 4S parts. I probably should have just started with a Mark 4S kit, is what it sounds like. And that will also allow me to re-lubricate everything properly. But yeah, it looks like your PG carrier of plastic, like this part here. It looks like that is probably PCCF, and the idler. So basically, back in the Mark IV setup, they said that all I had to do was basically strip it down to this, put the new cover on it. So it only just came with a cover, as far as I know. And basically, they just had me add some more lubricant. And those parts are also PCCF. It makes me think that they just copied and pasted this in there instead of making it specific to making it specific to the printer. the kit, the upgrade kit. I mean, so I don't know why they would have you repeat it. But yeah, this did not come with the PCCF upgrade parts for the next shooter. So I think they just copy and pasted it. How'd you screw up the gear and alignment? So the website seems to be messed up sometimes. Okay, handler nut, sensor. Now this is unique. Yeah, as far as I know, then I think I start from here. But yeah, I'm gonna skip all those parts and then basically just take the next extruder apart. I think once it's mounted, I can probably do a lot of this stuff. At least I'll know how to undo it. But yeah, all my little screw standoffs are here. The nylon standoffs, extruder spacers, and 10 screws. I think I'm putting the printer back on. So yeah, I think I'm just basically installing this on there as is with the love board and everything. Uh, so a 3x10s. Good thing is to take this off, you basically take the fan off and then you take the 3 screws off. And I believe the cables, I have to take the cable whip off. Okay, so now I'm back to putting a printer up on the table. Well, that was confusing. I'm never gonna have to verify why they do that. Okay. I might be able to get to everything from here. They want a cardboard box just to protect the bed. So, okay. Screw 3 extruder spacers to the extruder holder, tighten spacers firmly. Okay. Like one here. On here. These are kind of hard to install. I wonder if this works. Oh, it does. I only have one nut driver and it's a 7mm, and it happens to be the same size. Okay, they seem tight. Yeah, I feel like you can strip those out easily. Okay. But this is exciting. Put the next trigger on. Uh, Also, why they have 3 screws on here is because the whole thing is a heatsink, and the basically the flexure part, the whole thing kind of flex a little bit. Basically, it rotationally moves, as far as I can tell, and flexes up this the the load cell. So the load cell is on the very top. This is where your extruder nozzle goes through. So when this pushes down, this whole heatsink basically is a spring or a flexure. It's kind of neat. So do not over tighten. Yeah, you're screwing into nylon. Essentially, these are nylon pieces, as far as I know, and it's thermally isolating from the carriage, as far as I can tell. Uh, but yeah, it should look like that. Okay, and then the fan, which I already have. I want to essentially clean it. I think I did this last night, but I want to make sure it's clean. But yeah, this is not going to be a super straightforward build, because I am now missing upgrade pieces. But yeah, a lot of this is my fault for not using the Mark IVs. I might be the only person who has had to do a Mark IV for one upgrade. It'd be interesting to see if anybody else has done it and what their issues were. But essentially, right now, this is the main issue. The fan is completely covered in like white powder. from the plastics. And again, most of the parts, the only parts is if you don't have access to the PCCF parts, like that would be a problem because then you have to basically get PCCF and another printer to print it, which most people who buy in the Core One probably don't already have that. Um, so you get to get parts shipped from Prague, which is expensive, or printed solid. Hot end cable clip. I think this is it. And 3x4 and 3x18. Yeah, if you did, most people I think are going to need Core One assembled. Um, so fan faces like that. Put the fans in. Well, I got another 2 hours, 2.5 hours. I really want to get to the point where I basically only have to do panels. Just supposed to tighten them. But yeah, I think this only has to be tightened slightly. Yeah, so these two cables go through here. Oh, neither stop falling again. I'm gonna do the lower one. Oh, sorry. Yeah, that's basically tightly putting it in there. I think what actually, some of these are PETG parts. So some of the ones that are PETG, I guess, don't matter as much. Yeah, because the covers themselves are carbon fiber. They're probably higher temp. Four screws. One of these. And 5 of the nuts. What do you mean not screwed it off? I have 4. We're not. No. Oh, yeah. Definitely. Okay. I don't know if you can see all this, but oh, my camera died. Give me 1 second. And okay. Place the love board. Yeah, that's one problem I have with the GoPro, is it's using the webcam app. And yeah, the webcam app for the GoPro is not a stable solution. There you go. It goes like that. There you go. Also love board in. I didn't get the cable out. Like this orientation. And just wrap it around like that. I'm not show you. It's obstructed by the printer. Putting the sleeve right against that. Just twist the cable half a turn. So like that way. Okay. Insert 2 screws into the love port holder. I think I've done this wrong once. If you don't put them in this step, you'll be missing them. Yeah, I do remember doing this part of it. Okay. There we go. Now, you gotta make sure the textile strip sleeve is not correct in there. And this is gonna be yeah, if you forget these screws here, you can't get them in. And make sure it's smooth. Good. Okay. Then it looks like in the small parts bag, I'm getting a PTFE fitting. This is the, I believe they're Festo. No, they're not Festo. They're not Festo branded ones, but they're Festo style connectors, I guess. Teflon tube. Okay. M3×8. An M3×10. Swing arm assembly. Oh, they gotta have room for all this. Let me move this back a little bit. Oh, there goes the webcam. Okay, you didn't need that webcam anyway. Good thing NVIDIA broadcast is not showing what happened on camera. That'd be kind of cool. I should probably actually put the camera. Back up here. There you go. Yeah, I'm kind of crooked. You can kind of see me. Okay. I didn't realize there was blocking the camera. Yay! The camera works. The swing arm assembly and cable ties. Swing arm assembly, PTFE tube, 3 screws. Swing arm assembly. The bowline clip and the main clip. We're putting which direction? There does look like this direction with a screw head mount. Yeah, it's like there's an open corner in the back here. You basically feed the cable through like that. Oh God, that'd be really hard to get to. Okay. And then that puts the whole thing around. The panel of the core one, huge, huge. I had problems with my camera angle and to the thing. Yeah, I remember when you were filming it, you're not going to be able to see this. So I'm going to lift it up real quick. Without it getting in my way. You can kind of see what I'm doing. It's basically there. I have to get a screw in there. I kind of would like my cable sleeve to not be shown, so they say 15 centimeters, which is I could put quite a bit of cable sleeve in there, but I can adjust it, of course. Yeah, like that's a lot of cable sleeve. Really, the cable has to just go. I think there's a twist in it. But it looks like I'm using an M3x10. I'm going to put a screw in there first. Yeah, I gotta move the camera out of the way. I'm gonna twist this whole thing. Yeah, I remember this being really awkward to do. There we go. Easy. Okay. That's a joke. It wasn't easy. On the back of the extruder, attach the love board assembly to the extruder. Was that whole thing held in with? Yeah, I think the Bowden actually holds the whole assembly in. I did the same on my stream. I assembled a B-Lab with a camera and good angle, but then I put to are bad enough, I feel like. Yeah. Streaming is definitely a difficult task. So line the holes with the live board with the threaded holes at the top of the heatsink. Insert and tighten the fitting. Use the universal wrench. On the back of the extruder, tighten the 2 and 3/10s. Oh, this is the universal wrench. I see. That's not what they mean. Well, let me use my universal wrench. My flat jaw pliers. I might have an adjustable wrench, but I don't know where it is. I'm going to use this carefully. Okay, it's tight. And then there's 2 screws at the bottom. Oh, those screws. Oh my god, how did I expect you to get to these? Yeah, I just hope that they fit in somewhere. Oh, they're screwing into the back of the carriage. Okay, that makes sense. That's not too bad. Yeah, you just gotta make sure everything lines up. They also don't, like, you can have this cable twist. But I think that's what the cable mount for. That's just swing arm. Pair of threaded holes on the rear top panel. Okay. I like the samba music. This is great. Like reggae, samba, generic Caribbean. That's cute. It looks like a surprise face. I can't really show you, but essentially the two screw holes. You look here. There's a weld mark here that looks like a mouth, and then the two eyes. So it looks like a surprise face. Secure it with notice the cutouts on the swing arm. Position the main cable at the first cutout on the swing arm. There's zip ties right in here. Cable ties right here. One cable tie behind the first cutout, ensuring the correct orientation of the zip strip. So the eyelet is pointing downward. They're pulling it up. So I get it as tight as possible. Then I wrap it around. Three times. Yeah, it looks like mine. And then push the TFE tube. The centimeter. So I'm going to push. All right. A little too bad. That's it. Yeah, so I guess it's just kind of swivels on there. And closer. There you go. That's a PTFE tube parallel. You gotta show me where we're putting them. Yeah. There's only 3 places, so. Yeah, there's only 3 evenly spaced ones, so. Yeah, I think the next step's going to be panels. Pretty sure we're next. So. That looks good to me. I think there should be one here, but. Oh, the remaining 2 are about 10 centimeters each. That's easy. See, I actually like cable management. They're actually 4 centimeters? 10 centimeters? Oh, yeah, pretty much. Wow, I guess that one. I mean, you can adjust it too. There we go. My belts are super loose, so. I think I'm good. Yeah, that looks good. It's not going to hit the case. Yeah, that's what I want. I can always adjust it later. Yeah, thanks. Now I gotta do the fan. Yeah, they're saying the electronics package. But if you're doing a Mark IV upgrade, Mark IV's upgrade, it's from the printer. So I wouldn't have that. I mean, I would have it, but it would be the Mark IV, not the electronics package. M3 by 25 screw. With this one. Okay, so it's that one. M3 by 10s. And 3 square nuts. Insert the square nuts. This reminds me of Texas. This Tejano music. But Hispanic. Technically. And this is happy. Dark, happy cop. Now it's all pop music. So I guess it's Hispanic pop music. Interesting. That is satisfying having a single screw hold the fan in. Yeah, it was kind of cool. So you actually can take the whole neck extruder out if you just disconnect the cables. As far as I can tell, yeah, that's all you have to do is basically connect the cables, or disconnect the cables, take the side covers off, disconnect the cables, and then take the whole neck extruder assembly out. So you don't have to disconnect like a million things. Okay, did that part. Nope, and then we're going to take our original heater block out and the 2 thumb screws. Yeah, a lot of this they're assuming is part of the kit. Like, I feel like they just didn't fully write a separate manual. Like, they copied and pasted the upgrade to the Core 1 one, so you don't, it's not telling you which things are on the Mark IV or not. Luckily, I kind of have done this a lot of times, so. Yeah, this is a better cable management. The tool head side. Yeah, not completely. But yeah, you can actually tighten the thumb screws too much and actually bend the thin walls of the extruder nozzle. My battery just died. Give me 1 second. I'm gonna replace it. Okay, there we go. I don't know how long my mic has been dead. But anyway, it uses AA batteries, and I've been streaming for at least 12 hours or 6 hours now. Am I at 6? Yeah, 6, almost 7 hours. So I think at hour 9 I should be done with the most of it. This is going quickly though. Also, I need to put a sock on my extruder, so there you go. Now you can see there's a sock completely over an extruder. And I believe this is a high flow, 0.4 brass high flow. It's not an obsidian. You put it all the way up, and it's tilted slightly to the left, as most things should be. That was not a joke. I mean, that was just... Never mind. Seeing if anybody's paying attention. Yeah, don't crank your extruder nozzle that much because you can clog it. But it has to be secure so it's not coming down. There's ridges on it to basically make sure mount. Oh, good. There's a Elkton alerts. Great. So lock your doors. Hey. Now it's connected to the heatsink. Like the thermistor cable above the main cable on the load board. Okay. Okay. There's a cable organizer thing that goes right. I think they actually show you. There we go. There's a little clip that holds the hot end thermistor cable in. Like the hot end fan cable, the lowest end, that. What's the NTC on? Yeah, the heatsink one is the NTC, I think. Yeah, that makes more sense. Actually, you don't want to twist these cables because then it'll be hard to get this out. You want the thermistor cable over and top of the other ones. Yeah, the thermistor cable, because you want to be able to pull the whole heatsink out without having to take all the other wires off. Okay. You also want to get it so that the wires aren't interfering with your cable cover. So you can pinch those too. They might tell you to guide the hot end thermistor. There's a cable clip on the side. Yeah. There you go. There's a cable clip on the side of here. Yeah, so the thermistor is hot end is a different thermistor than the NTC. The NTC is the one that they call the heatsink thermistor. And that's the hot end connector. Just squish all these wires. I think the cover actually holds them back. It's probably the next step. Got the print fan cable through the channel on the plastic cover. Okay. Create a loop with the print row cable. Go in the middle. Mine is pretty long. I can just twist it. Just gonna shove it all in there. Plug an extruder motor. A top facing connector. Lid cell cable. Just a twisted colored cable. Okay. Can't really see that, but I did it. Right. Yeah. Oh, so on the bottom. Oh, now there's the upgrade cover. This is the old cover. This is the new cover. So the new one comes with a thing sticking up. And then into the 10s. And in 3x6s. Let me move the whole thing around so we can see more of the side piece. This thing has to be pretty tight because if this thing moves out at all, yeah, sure it's not covering anything up. Yeah. Squeeze the wiring harness. That's the print head cover. Oh, okay. Can't see that screw. Ah, it's there you go. That's good. Oh, right in there. I'm glad they made a cover that gives you a lot more space for the love board, but the Mark IV did not have that much space. I was pinching the cable. There we go. Not pinching any cables. Either can open. Nothing is completely shoved in there. All the cables look like they're free. It even hides some of the motor, the extruder motor. Yeah, I think I did good. I don't know why it's like that. Okay, guide all the main cables to the hole. Okay, we're gonna shove it all in there. Oh, the rubber gromet's gone. I don't know. I'll do it later. I highly recommend that you get a lazy suit. I think. I think a lazy suit is going into so much here. All the tools are dropping. Okay. What the hell is I think? Okay. We were doing more stuff. One thing they did is they gave me an extra grommet. I set 2 sets of grommets basically. I'm gonna put 1 set in here. They don't tell you to do that, but it just looks nice. There we go. At the main cable through the left hole of the buddy box. They really want you to try to squeeze everything in there. If you turn it sideways, it might be easier. Yep. That wasn't too bad. Hey, main cable. Yeah, they don't give you much play with, but just enough to click it in place. There we go. Yeah, that wasn't too hard. Oh, we're out of music. There we go. Security cables were the. But mine looks pretty much like that. Now there's a part that I would think can be interpreted differently. We're not done with the this yet, but I do want to thread this so that it is. I think I'm going to do this where I basically zip tie a loop around the power cables and do like one tie point in the middle to tie all these cables together. And then you get a perfect like straight flat loop and nothing's hanging down. I cut out the excess. So I'm pretty much to the panel side step, I think, now. Uh, the left and right sides are different. And there's 8 screws. 1, 2, 3, 4, 5, 6. Okay. I'm going to rotate this whole thing again. And okay. And whoop. This is the right panel. So luckily the core XY screws are accurate. If they're not lining up, then it's your rods are not accurate, or your core XY stage is not fully seated. So far, all the holes are going in correctly. Okay. So that's tight. That's tight. That's tight. And then that one's tight. Okay. Left span, I'll ensure you're using the correct profile. 2 large round openings for the door and the door sensor. Align the profiles. Pair to the core XY frame. Yeah, the door switch does activate. It's a little low. There you go. There's a lot of rigidity because they triangulate a lot of the panels. But these structures are actually structural, not just for show. Yeah, like these cutouts, there's a precision cutout, so these panels have to fit basically perfectly together. If there's any bends in the steel, it won't fit, which is crazy. So yeah, if any of this stuff gets damaged in shipping, it won't fit together. I think these things can take some abuse though. Top profiles. Okay. There's 4 profiles, and there's one with four screws. I want to make sure I'm using the right screw. Correct. Okay. I didn't mix up the screws. There you go. Yep. These are all tight. Okay, so now I got 1 more hour. I'm probably gonna do the plexi myself. I'm gonna end the stream, probably do the plexi myself. I don't think that's as interesting. What I'll probably end up doing is, because I wanted to stop at 9, I might do one tomorrow, and it will just be, it might just be calibration and tuning. We'll see. I don't know how close I am, because there's a lot more. There's profiles, all the sensors, the NFC cable. I mean, there's a lot of little things. So I want to get through this to get to the bodywork, the trim and door and LCD. That stuff I think I'm going to do on my own. I don't think there's anything really interesting because I've already done some of the sub-assemblies. Plus, I don't think I'm going to have enough time tomorrow after work to do a full stream. So I kind of want to get it done to the point where I am basically printing and calibration and stuff. So a different type head. Okay, where is that screw? M3x4 black screw. Apparently isn't here. There's set screws. Here we go. Yeah, one spare. And the rivets I have in here. I got a bunch of rivets. Okay. I think I can move the whole machine over real quick. Yes, there's room for the top panel. Place any of that. So these actually use M3x4 cap head screws. They're a different type of screw, and I think it's to align the top panel. There's two pieces of metal tabs, and they have to lay perfectly flat to make it 90 degrees. Yeah, there we go. So but yeah, you can see that these metal tabs actually, this whole piece has to be flat. You might have overlapping joints. So this has the same thing. So it's like this. Oh yeah, they're two profiles that form a corner. Um, yeah, one is over, one is under. Yeah, that's much faster. Okay. Yes, I could probably move this around, but I just want to get it done. Tighten 04. God. Okay. Yes. Position in the rear of the printer. Okay. Looks like we're going to be moving there again. So this is not going to fit into my workbench, so I'm going to have to basically uh, do it one side at a time. Looks like I can uh, uh, lift it myself. That's a workout, just to lift this thing. And I'm putting it like right on the edge of the table too. Okay. Um, but yeah, as far as I know, the back two screws are for the Mark IV, so the MMU3. Oh, it's taking shape. A little off. There we go. There we go. That's better. Now everything fits nicely on there. Or as I can tell, snug. Okay. Must be positioned behind the back sheet metal plate. Yep. Okay. Okay, now I gotta rotate it 180 degrees. I'm assuming I don't need that box anymore. Okay. Okay. Nope. Eh. So if anybody asks me if I'm gonna backpack this printer, I'm gonna say no. I thought about it. I might just do it as a gag to do it like once. Just do like a temporary frame, or actually just add straps temporarily to it, to the back of it, and then with a pillow or something, just so I don't have like a lot of involvement. Battery should be really easy. Battery should just tuck underneath here. I can power it off of just a basic tube drill batteries and a step converter. This printer actually would be a really good backpack printer, but I'd have to do it as a gag because there's no reason to do this. It's way too heavy. Yeah, and then there's 3 rivets in the back. I think I stripped that thread. Three plastic rivets in the back. Okay. Okay, so you have to loosen that back screw. That one that was in the oval is slightly loose, but you basically have to lift the core XY stage. Now you're actually securing the full stage. Ugh. Right. I have one more screw on the back here. Yeah, this is a lot. See why we built assembly carts. Because it's so much easier to be able to roll them around and keep them at eye level. Okay. I've done the sensor already for anybody who's still watching. This is the new one. It has the orange piece. I'll show it on video. Essentially, it's a little ball bearing. A little ball bearing. So when it's basically when it's locked, there's a little ball bearing in there that essentially rides in a groove, and the lever pushes up against the ball bearing, and the magnets oppose each other. The orange piece, when the orange piece is slid in, the magnets oppose each other. The lever goes downward and blocks the light sensor. And then if you pull the lever back, it actually reverses the polarity of the magnet and actually pulls the ball detent down and deactivates the door sensor. So, or activates the door the filament sensor. So it thinks that there's filament. If you pull this out, it feels like it thinks that there's filament in there. And that's how you load like soft materials like TPU, stuff that's really hard to load in there. And then when you're doing harder materials, the filament sensor is activated if you do it this way. So basically, it's a way to deactivate and activate the filament sensor, it's a way to bypass the filament sensor mechanically. It's really clever. And yeah, it has basically an optical sensor, and it's blocking it with a flag. And then we're gonna zip tie it to the left side of the machine. Spot or the right side of the machine. You cannot put the filament spool holder on the left side unless you put like a really long reverse button. And the sensor cable wouldn't fit. You'd have to extend the sensor cable. This is just a pet peeve, but I want to hide the motor cable behind the sleeve. There you go. It looks nicer if you hide the cable behind the motor cable because it's all black. So we're putting one zip tie in. I think we're really close to putting the panel on. Yeah, plexi isn't going to be super difficult. It's just the door. I just don't want to do it on stream, honestly. But I probably will get it to the point where I can calibrate it. Yeah, I think I'm going to stop it out for that because I probably have to go eat and do everything else. And at this point, I think any stream content I would have is going to be cut short. But I know this is the VODs, though. Yeah, normally I would, though. I would push through and do it all today. But I also realize that I have like a normal life. Let's see. We will attach a cable near the metal profile, insert the collet into the arced opening. I've already done that. Attach the sensor assembly onto the PTFE tube in the printer. Okay. It should go all the way in. Okay. And sensor cable kind of goes on the inside. Like that. But yeah, make sure you push it all the way in. Move the sensor assembly up roughly into the middle of the printer frame. Okay. Once in position, secure the cable underneath the metal profile using a zip tie. Tighten the zip tie slightly. Line for the cable. Judgment. Cut off the axis. Guide the sensor cable through. Guide the cable through. Yeah, that's what they're doing. Okay. Okay. All over through here. Sensor wires there. And then zip tie. You can't really see it, but I'll do a cable on this side. Okay, so we're feeding it into the same gland. I wish they would do this before they did all the electronics. They're too tight now. I gotta like add it over the other cables, and it's pretty short. And then you probably get the panel. Okay, so it goes into the filament switch, which is right here. All right. So basically, we're gonna create like all the excess. I'm gonna tie it up like this. Like that. Yeah, that's really tight. The screw holes are here though, so. Okay. I mean, a lot of it's manageable. And so I can probably, I'll do one zip tie here. Kind of get all of these combined. Okay. I'll do the cover. NFC sticker. And and 3x10s. NFC coil thing and the cable, which I think that all comes in here. Ground myself. Okay. I actually have, well, um, so peel off the yellow protective film. Okay. Apply the film to the flat side of the NFC, ensuring it adheres properly. I just did it right center there. Apply the film. And then peel the rest of the tape. Okay. The really thin double-sided tape. Stick the NFC coil into the inside like shown. There you go. I hate these connectors, but they're fairly easy once you feel it. There you go. Click. Locate the small round connector. Label NFC at the bottom left of the buddy board until you feel it click. There you go. Click. Okay, use this picture to reference the verify electronics. Make sure all fully inserted power supply cables. Tie another. Yeah, cooling fans, side sensor, temperature sensor, and LED strip, RGB LED, X, Y, X, Y, skip one, Z, body extension, LCD, main cable, power panic, heat bed thermistor, NFC antenna, door sensor, um, heat bed cables, positive, negative, power supply cables, red, black, red, black. See how they organize their cables a lot different than I do, but I guess that works either way. But yeah, I'm gonna run one cable, have it this way, and then take a picture so that I can. There you go. Beautiful. I'm gonna take a picture for Facebook. Nobody cares. They won't even know what this is. Okay. Probably Blue Sky or part of Instagram, I guess. It's the part you'll never see of the printer. Just verifying what all the cables look like. Man, they get tight like this other one. There's like 2 expansion boards worth of like 4 expansion headers and another motor header. And the 2 and 3x10 covers. So these kind of suck because you have to get them in for a really long hole. There you go. The printed part is the issue. There we go. Easy. There is plenty of room inside that cover, though. Um, what I think they can do is they can probably put another NFC wire into the spool holder, run it all the way through here, and that way it can detect the spools. Sure, the threaded hole is on the bottom and not obstructed. Yeah, NFC cable is not in the way. You're planning to use a buddy camera. You have a USB cable installed already. Obviously not, because I don't get a cable with mine. I think I'm going to have to install my own cable, which means I have to cut the zip ties and redo them on the side, and then run it through the back box. We'll see. I might do that tomorrow, but probably not. But yeah, no camera. Okay, 2 more pieces of steel. Where is that? 203 and 303. Three or three. And actually, I've not opened 203 yet. But those are the side panels. I wish I had room to show you the packaging, because the packaging is really cool. It's a really cool part of this. I think there's 8. Curious. Good thing I didn't have a drink in there. That was the phone stand. The one the photos, not photos, man. Clock Spring has a phone stand print, which is really nice, but because it's print in place, but it's Well, too late. I'm not arranging my cables like that. Uh, Man, so close. Jeez. There's 6 screws for the back panel and then 2 for the cover panel. Something is sliding. I think it's the metal on my bed. The metal covers. Oh my god. Why happened with the music? Jeez. Next time I'm finding a legit music source. The music thing needs, I just want to be able to press play and it plays generic stream music. Like doesn't matter what it is. I just don't want to get copyright strikes. And I don't want it to be so dry. Alright, we're still on track. Okay, that's done. the right side piece. That should be easy, but I'm just gonna even that here. Damn, that's a super heavy. It's like 50 pounds, I think. Or about 30, no, it's 30 kilograms. It's like more than 50 pounds. It's very significant. Side panel. And then the puck. And a cardboard box I have behind me. And more screws. I think that's all of them. Gosh, not M3x4, M3x8. Okay, so we do have just enough. Four. One, two, three, four. Four. Oh, I only need 4 of them, but I'm up 9 o'clock. I get the panel on, and I think the plexi will be a separate step. And I think the other side is just rivets, so I don't think we're that far away. I think I have to put the filament sensor on the side. Oh yeah, the handle. Okay, and now the little grommet pack. And 2 screws. And 3/8. And 3/8. All it. And rivets. I think this is gonna be really hard to do. Okay. I gotta place it so I can get to it. Side. Okay. Really hard to get the hole lined up with the sensor. There we go. Yeah, that's hard to do. You basically have to line up the handle and the sensor all together. What they should have done is put a full cutout and then just yeah, the rivets actually are probably one of the better parts of this. I never had problems with the rivets. I say that as I mess one up. I know that's not what that tool's for. But if you line up the holes, it's pretty easy. Honestly, it's probably the most satisfying part of this whole thing. The rivets. I'm just noticing how many panel gaps there are. There's a lot of empty panel gap space. Like, I think there's a mod to, yeah, 1, 2, 3. I think there's a mod that basically covers all the gaps. So 2, 3, 4, 9, 10, 11. Okay. And then that PTFE2. Push it all the way in. There's really not much sticking out either. Okay. And the left side, I'm just gonna do the left side because I gotta turn it over anyway. Oh, God. These squash balls are squashed. That's funny. They're so heavy that the squash balls just completely collapse under the weight. And 3x5s. T55 RT. I don't know why there's so many excess screws. Can't think of any other parts. I think the only thing is there might be a few neck extruder screws that it provided, but yeah, I've been going crazy. This thing is so heavy, and I've lifted up and down so many times. I'm almost there. And a million more rivets. I'm just gonna do these on the chair behind me, so maybe you can see it. These are threaded. Now I get it. This is super tedious. I mean, I think what took me the longest was definitely finding the parts has taken the longest time. And then the next extruder assembly was a little bit more complicated than I thought it was going to be. Actually, it wasn't too bad because I didn't have to build the next extruder. But now that I know I have to rebuild the whole next extruder, I don't have to rebuild the whole thing, but now I know I can take the whole next extruder off and update the parts on it. So I just need to get some, as far as I know, I got all the mechanical parts. I just need the PCCF parts. So I think I have pretty much everything else. Nothing else changes, so. But this is the fun stuff. To me, Plexi and doing Plexi and side panels and final assembly stuff is kind of fun. The not so fun part is like, I don't know. Actually, all of it was not bad. It just seems like there's a million steps that they don't prepare you for. Also, imagine a Game Changer episode where the whole Game Changer episode is to build a 3D printer. It's like, surprise! Sponsored by Joseph Prusa. That's a great idea, actually. It probably wouldn't be fun, though. Like, as fun as people think it would be. Like, can be comedians that don't know how to do mechanical stuff trying to figure out a 3D printer. And it'd be funny because it'd be like the one comedian that actually does know how to do mechanical stuff. But what's better, improv, is trying to build a 3D printer from a prompt. Yeah, okay. One thing at a time. God, one more chat and then get enough out. I should make the MMU project. That would be a good stream though. Rebuilding an MMU from an MMU2, or just building an MMU3 from scratch. Essentially. Okay. Now, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I like that. So this is going to be on the left side of my desk, which I don't have access to, because I'm going to have a TV entertainment center. So there's almost no reason, there's nothing that I can put here. So I don't know, maybe I could remove it and do something with it. but it is structural, so. Come on, be it. Come on, that's it. Thank God. Okay. I'm really stopping here. I'm gonna do plexi. I'm pretty sure I'm gonna do plexi and door trim and all this stuff off camera. And then tomorrow we'll do calibration. Yeah, let's do calibration first run tomorrow night. I'm gonna do door trim and doors and LCD and all that stuff tonight. Because it's not, well, I might get all of it, I don't know, but I feel like I can do this a lot faster and it's not as interesting. But I'm gonna end the stream here. This is the Core 1, almost complete Core 1 conversion. Let me turn it around and get it. Oh, that, and that's so much weight to it. It's like 60. Yeah, it's about 60 pounds, I think. That's like a small child. Okay. Yep, there it is. Core 1. The mostly complete Core 1. That's huge. I mean, it's super useful. It's nice that it's steel, but like, it is an actual echo chamber. This thing is just a big steel drum. I don't think you can pick it up on the mic, but it is loud. I really think Dynamat. Like, there's no room on the back because of the cable, but like, even dampening in the corners. I think like putting some foam in the corners, or something. I think the inside of these panels should definitely be covered. I think up here, and then maybe the whole back, the back panel could probably be partially covered, and the bottom here has, yeah, there's enough room that I could put a thin sheet of insulation down here. But yeah, this thing can be quieted a lot, I think. But I think the squash balls are going to do a lot of work on the quieting, because it's not going to vibrate through my desk. So, okay, I'm done. I'm going to do the rest of this tonight after I take a shower. I don't think I'll spend more than an hour on it. We'll figure out what I'm going to do with food, but I can do the rest tomorrow. Okay, I'm ending the stream. Thank you for joining. So next one will be day 4. And good night.